stuff out. Today, I'm dressed up fancy because your questions have inspired me to have a big star on the show. The biggest, most famous star on Earth. Wait, did I say on Earth? I mean, the biggest star in our whole solar system. Put your hands together for the sun.
Yeah, the sun. Yeah, the sun. I love the sun.
Yes, the sun truly is a star. But if it's so great, then how come, as Anastasia asks,
why can't everything be solar powered?
solar is another word for sun, as in energy from the sun.
The sun is very, very big compared to the planets in our solar system, including Earth, and it also has unimaginable amounts of energy.
So I wonder, maybe everything could be powered by the sun. Like this solar-powered baseball cap with a fan to keep me cool. Or this solar-powered bobblehead.
And how about using the sun to cook food?
This is a solar cooker I made. It doesn't need any electricity or flames to cook things, just sunlight. Well, that's what they say. But is it really true? Let's check back at the end of the show to see what happens to this egg. Meanwhile, you sent me a lot of other questions about the sun that need to be answered, like this one from James.
What is the sun made of?
Well, James, I checked and found out that the sun is a giant ball of super hot gas, mostly hydrogen and helium. Some of it is like what's inside of this helium balloon. But what's happening to the gases inside of the sun is incredible. Here's why.
Gravity is a force that holds us onto the Earth and keeps us from being flung out into space as it spins. Without it, this would happen. The sun is huge compared to the Earth, so its gravity pulls on the Earth and all the other planets in our solar system, so they circle around the sun.
The sun's gravity is so powerful, it actually squashes the hydrogen in its core, which is this part deep inside it.
When that happens, it creates incredible amounts of energy as it turns the hydrogen into helium.
Okay, my balloon isn't really doing that. It's not big enough to have that kind of gravity, but if I squish it enough, maybe it'll create enough pressure to have my own mini sun and power something. I'm not giving up. I'm going to bring in an expert to help me do this. She discovers galaxies, so I bet she can help me. Please welcome my special guest, astrophysicist, Dr. Tracy Webb.
Hey, Harrison.
Hey.
I brought you a picture.
Whoa, is that anybody I know?
Well, it might look familiar. It's a galaxy, very much like our own Milky Way galaxy, the one that the sun lives in.
What is a galaxy?
Well, a galaxy is a collection of usually billions or even tens of billions of stars, which are held together in space by their own mutual gravity. They're kind of like an island universe within the universe itself.
Wow, billions of stars. If Tracy knows that much about space, maybe she can help me make my own sun.
Okay, so I have this balloon filled with helium and a bit of hydrogen, just like the sun. Yes, I'm gonna compress you into a sun with this. Oh, it's almost there. It's getting warm. I can feel the heat building up. Oh, now I don't have Mr. Sun or Mr. Balloon. But at least I still have you, Tracy. What went wrong?
Well, the hydrogen and the helium in the balloon doesn't actually want to be squished together. So it fights back. That's what we call pressure. And you're just not strong enough to squish all of those atoms together. But I can show you what's happening in the center of the sun using this demonstration with Play-Doh.
Okay.
We're going to pretend that these 4 yellow Play-Doh balls are hydrogen atoms. And now we're going to put 100 million elephants on top of it.
I don't have 100 million elephants.
And that's going to create the pressure, like the pressure in the core of the sun, and it's going to squish these hydrogen atoms together to form helium. And when it does that, it releases energy.
Well, I don't know where I'm going to find 100 million elephants, but I do know where to find another question.
Why is the sun a star?
Yeah, why is the sun a star?
Well, the sun is a star like every other star that we see in the sky. It just looks different because it's so much closer to us. And for a long time, we did think that it was something different, but now we know that it's not. But it's still a really important star because it's the center of our own solar system, and it is the brightest thing in the sky.
That's right, Mr. Sun. You'll always be special to us. Even if out there you're just one of millions. I mean, billions. I mean, how many stars are there?
There's over 1 billion stars in our own galaxy, and there are billions and billions of galaxies in the universe.
So would it be like how many grains of sand are in this bucket?
Nope, there's more than that.
More than this? What about the grains of sand in this whole pool here?
No, you would have to take more grains of sand than are on all of the world's beaches, and you probably still wouldn't even have enough stars.
Yeah, my parents aren't gonna let me bring more sand in here. So let's bring back the sun for another question. That's bright.
Why, when you look at the sun, your eyes burn?
Yeah, why is that?
Well, unlike the stars, the sun is really close to us, so the light from the sun is still very energetic when it reaches the Earth. The stuff that damages your eyes is called ultraviolet light, and you can't see it, and you can't feel it actually burning your eyes.
So it's kind of like when I go to the beach, I put on sunscreen.
Yeah, it's the same stuff that gives you a sunburn, and you don't know that you're getting a sunburn until it's too late also.
What about during an eclipse?
During an eclipse is when the moon passes in front of the sun and blocks all the visible light, but it doesn't actually block the UV light. That can still come through to your eyes even though you can't feel it or see it.
So you should never look into the sun even during an eclipse?
Never.
Are all the sun's invisible rays dangerous?
No, not all of them. And in fact, some of the stuff that comes, some of the energy that comes from the sun can produce things that are very beautiful on Earth, like the northern lights.
Oh, I think I have some video of that. They're so beautiful. What makes them happen?
Well, you remember that I said the sun was a big ball of gas, and that gas was made up of particles of hydrogen and helium. And a lot of those particles are being blown off from the surface of the sun all the time, and we call this the solar wind. And that wind of particles goes through space and gets captured by the Earth in the North and the South Pole. And as those particles come down into our atmosphere, they collide with other particles, oxygen and nitrogen, and cause this explosion of light that we see.
The experiment.
For those of you who have never seen the Northern Lights, you can do a quick little experiment at home to see what they look like.
Awesome.
So get an adult to help you assemble all these different ingredients. You need some 2% or whole milk. You need some pretty food coloring colors.
Yeah.
And some regular dish soap.
Okay.
And what we're gonna do is we're going to pour the milk into this pie plate here.
Okay.
And then once it's settled down just a little bit, we're gonna put some green in and some red. We don't want them to mix yet, so I'm putting them separately.
Right.
And then
The
some
blue.
blue.
Whoa.
And then I'm gonna take the dish soap and just put a little bit right in the middle.
Whoa. Cool.
So you see how it makes swirls and curtains? That's exactly what the Northern Lights look like.
Cool. Thanks for helping us find stuff out. Now here's a question from James.
What would happen if someone walked on the sun?
The short answer is the worst sunburn you'll ever have in your life. And that would be a very short life if you tried to walk on the sun, because it's so hot. Yikes! My toesies! The sun is so hot, you wouldn't even be able to get close enough to walk on it. But if you could beam yourself up onto it, you'd be burned up in less than a second. And it's not solid anyway, so it'd be like trying to walk on a burning cloud. Scary. Which leads to a question from Kevin.
How hot is the sun?
How hot is it? Hot enough to give me a sunburn. Hot enough to melt crayons. The sun is hotter than all the candles, hotter than an oven, hotter than a furnace, hotter than my head, which is getting really hot. 150 million kilometers times all those degrees. Solar meltdown, here I come. Ah!
You're gonna make my head explode.
I checked and found out that the hottest thing on Earth is the lava from a volcano.
It can be 1,300 degrees Celsius. That's 40 times hotter than a really hot summer day. But the surface of the sun is 6,000 degrees. That's more than 4 times hotter than a volcano. But the center of the sun is way hotter than that. 15 million degrees. That's more than 11,000 times hotter than a volcano.
Luckily for us, we're just the right distance away from the sun's heat. Scientists call it the Goldilocks effect. It's kind of like this.
If the Earth was further away from the sun than it is now, like where Mars is, the sun's heat wouldn't reach us and warm the Earth enough for life to exist. Aw, my porridge is too cold. In fact, everything is too cold. If the Earth was closer to the sun, like where Venus is, the sun's heat would be too strong. Huh? And now my porridge is on fire! Ah! Person, get me out of here! Ah, not too hot, not too cold. Everything is just right. Except someone ate all my porridge!
Excuse me.
Why does the sun have to come out in the day and not at night?
The Flat Earth Corner!
You want to know the answer? Well, you've come to the right place. I'm Homer, the famous Greek poet from the 9th century BC. So, why does the sun come up in the morning and go away at night? Well, as anybody in ancient Greece who's read my work knows, duh, it's because the sun god Helios rides his sun chariot across the sky every morning and disappears at night. Like this. Whoa. Whoa. Yeah! This is so much fun! I told you. Nowadays, we know that the sun is the center of our solar system, and the Earth circles around it, spinning. So unless you live in the North or South Pole, the sun comes up in the morning and goes away at night, like this.
The Earth. It spins around and around, so the sun comes up and the sun goes down. At night, we're turned away from the sun, but it's back again when the morning comes. At night, we're turned away from the sun, but it's back again when the morning comes.
We have morning and night because the Earth is always spinning. That gave the ancient people a solar-powered way to tell the time before clocks and watches were invented. It's called a sundial. Thousands of years ago, people used it to tell the time. It works by the sun casting a shadow on it. And that's today's
My Great Challenge!
Today, my great challengers are Amelia and Mateo.
The awesomest.
Okay, so you're gonna be Team Ra after the Egyptian sun god. Yeah. And you're gonna be Team Sana after the Viking sun goddess. So your challenge today is to find out the time using the sun. Well, actually it's a flashlight, but it will represent the sun.
I've made a giant sundial on the floor. The piece of a sundial that casts the shadow is called a gnomon.
Each one of you will try to find 2 different times of the day at different times of the year. The one to do it in the shortest time will be the winner. And remember, in the northern hemisphere, the sun lays low in the winter and it's high in the sky in the summer.
That's why there's 2 rows of numbers on my sundial. These are the summer times, and these are the winter times.
So Team Ra, you're gonna be first, and Team Sana, you can go downstairs so you can't cheat. Okay, here's your sun. Your first challenge is to find 9 a.m. in January. Go.
Mateo is moving the gnomon onto the square for January. Good move. He gets his shadow in the right direction, but here's the tricky part.
Yep, remember you have to have the point on the number.
Mateo needs to try and make his shadow shorter. He's raising his sun, now lowering it.
And there you have it.
That's about how high in the sky the sun would be at 9 a.m. in January. Now let's see how Amelia does.
Are you ready for the first challenge?
Yeah.
Okay, 9 a.m. in January. Go.
Amelia quickly puts down her shadow caster. Now she's got to get the shadow to point to 9 a.m. Close, but that's 10 o'clock. She's moving the sun over, but it's got to be at the right height in the sky. She's raising it higher in the sky now, hitting 9 o'clock. But that would be where the sun hits in the summertime.
Remember, it's January.
Amelia's lowering the sun a bit.
There, she has it. Okay.
Amelia does it in 1 minute and 22 seconds.
Okay, are you ready for your second challenge?
Yes.
4 p.m. in July. Go!
The sun in the summer is higher in the sky. Let's see if the challengers figure it out. Mateo raises his sun. He's found the sun's position at 4 o'clock in the winter. But I asked for 4 o'clock in July.
On July.
And there you go, he's found it. Second challenge, go!
Amelia rushes to make up for lost time. Oh, it looks like she learned from last time.
Okay, you're getting really close. There, she has it.
And she did it! Now let's see who had the fastest combined times.
Okay, so Team Sana, you had a time of 1 minute and 44 seconds. Pretty good. And Team Ra, you had a time of 1 minute and 1 second. You're the winner. Woo, yeah. So, thank you for playing my great challenge. Now here's another sun question.
How do solar panels work?
Well, I know they take light and turn it into electricity, but I don't know how. So I went somewhere very cool to find out. This is Monty Gisborne, and he knows all about solar panels and how they work. And this is a solar-powered boat, and he's offered to take me on a ride. Thanks, Monty.
My pleasure, Harrison. Welcome aboard the Osprey, North America's largest solar-powered vessel.
Awesome.
Let's go.
This boat is much quieter than a gas-powered boat because its motors are electric and are powered by solar panels.
What we have here to show you is a solar panel, which is
Okay.
the primary source of energy that goes into this boat.
Right.
Basically, the rays from the sun strike upon the panel and excite the molecules of these crystals, which in turn creates electrons. Electrons is what electricity is made of.
Right.
The electrons start to flow through all of these cells individually.
Okay.
And that creates a circuit that flows through these wires, and then that energy is available for when our captain here needs to hit the throttle and make the boat go forward.
Okay.
I'm getting worried, though. We've traveled far, and it's getting kind of cloudy.
So if it got cloudy, like right now, would the boat just stop, or would it keep going, or how would that work?
Well, the truth is,
Uh-oh, I can feel bad news coming.
this battery pack is about 10 kilowatt hours.
Oh, good. That sounds like a lot.
That's about $1 worth of electricity,
We're doomed.
but that can run this boat for about 5 hours.
That's like a day's trip right there.
There it is.
Perfect.
We've got plenty of battery power left for me to drive us back. Good thing I have my boating license. And the best thing about this boat is it doesn't pollute. Solar power ahoy!
Well, this is great. If you could have anything that was solar powered, what would it be?
A car and a computer. A car.
A car, maybe like your toy car?
TV. Cars, because if you use fuel or gas, it will ruin the environment.
I would do different public buildings like hospitals or schools, because then anyone in the world could use them.
Nice. And what about you?
A blender and a bathtub, because I really like both of those things.
A blender and a bathtub. Those are two of my favorite things too, but don't combine them. That's a bad idea. And that brings me back to the question that started this solar quest.
Why can't everything be solar powered?
Well, Anastasia, the big answer is... almost everything does run on solar power, indirectly at least. Plants use the sun's energy to grow.
The wind that sailboats and wind generators use is made by the sun heating up the air. The rivers that run hydroelectric plants need the sun too. The sun evaporates the water, carrying it up to the sky where it cools, falls as rain or snow, then eventually flows down into the rivers again. Even the gasoline that we use to run our cars and the coal that we use to run some electrical generators were once, long ago, living plants that depended on the sun for energy.
But I think you mean, why can't we get all of our power from solar panels? Well, maybe one day we can.
Scientists are developing solar panels that can capture more and more of the sun's energy and convert it into electricity better than solar panels used today.
Hey, that reminds me. It's time to check on my egg. Oh, that's hot. I'll use this. Oh, it worked. That's excellent. So maybe by the time we're grown-ups, our cars, schools, businesses, and homes, and everything inside them will be solar-powered by the sun. But until then, I'm gonna wear this solar-powered hat to keep cool. Ah, that's better. See you next time for more Finding Stuff Out. Hey, this banana got its energy from the sun, and now I'm eating it. So I guess I'm solar-powered too. You want a bite? Well, I guess you'd rather have your solar power direct. Solar power.
You bet.
Hi, welcome to Finding Stuff Out, the show where I answer your burning questions of the day. Like...
Why does the moon follow us?
Yes, Carl, why does the moon follow us? I wondered that myself recently while I was out for a walk.
Did you ever get the feeling that you were being followed? That's weird. It's you!
I caught the moon following me. Why does the moon follow us?
I don't know, but we're about to find out what tricks that moon is up to. And by the end of the show, I'll have the answer to your question.
Here's one from Jessica.
Why is there a moon?
Why is there a moon? I don't know. I know that it's there in the sky, but I've never really thought about why. And now you've got me thinking about it a lot. Did it just show up on our doorstep one day? Like a cat? It's mind-boggling. How did something so big get there? Why is there a moon? Ah! Yay!
You're going to make my head explode!
To answer your question, I went to the moon. Just kidding. If I really was on the moon, my face would expand and I wouldn't be able to breathe. Hey! Hey, Rover, are you following me too now? But seriously, I'm here today at the Canadian Space Agency in a place called the Sandbox, which is very similar to the surface of the moon. And here I am with Caroline Emmanuel Morissette, who's a lunar geologist.
Hi, Addison.
Hi. So what is the whole point of this sandbox?
Well, we can use it to practice for possible future lunar missions.
The astronauts practice down here, so they know what to do on the real moon. This is the perfect place to answer your question. Why is there a moon? Caroline says that most scientists think it's because of something called the giant impact.
The giant impact theory.
So did it involve giants like Jack and the Beanstalk swinging clubs like this?
No, it didn't.
Caroline tells me that according to the giant impact theory, billions of years ago, an asteroid as big as Mars smashed into the Earth. Parts of the Earth and parts of the asteroid shattered into pieces, then joined together to form the moon that we now see in our sky.
So in all the vastness of space, there's a chocolate cupcake orbiting around the sun, minding his own business, when all of a sudden, whoosh, hey there, buddy, this is my orbit. Get your own, pal. I'm sorry, I'm out of control, I can't help it. Yes, you can. Out of all the orbits in the galaxy, you had to choose mine. Whoa! Hey, you got vanilla icing all over me. No, you got chocolate icing all over me.
So the moon is made up of bits of vanilla cupcake and chocolate cupcake. Or, as an astronomer would put it, the moon is made up of bits of the Earth and bits of the asteroid that hit the Earth.
Next question.
Why does the moon have bumps like that?
Yeah, why does the moon have so many bumps?
When the Earth and the moon formed,
Caroline says when the Earth and the moon were made billions of years ago, there was so much stuff floating around in space that rocks and planets were always bashing into each other. Even today, new craters get made on the moon. It happens when meteoroids, that's stone or metal debris from space, crash into it.
Wow, I made my own mini crater.
I wondered why those meteoroids don't hit the Earth too. Caroline tells me it's because the Earth's atmosphere is like a shield. The meteoroids burn up when they try to get in. When you see a shooting star, it's really a meteoroid burning up in the Earth's atmosphere. But the moon doesn't have an atmosphere to shield it, so it gets hit.
How big can the craters be?
Well, some are very large, so you could take a day to cross them in a car.
What? That's crazy.
Yeah.
So thanks for being on my show and helping me find stuff out. It was out of this world.
Oh, well, it's my pleasure, Harrison. Thank you.
Okay, Rover, ready? Oh, good boy! Yeah! Good boy, Rover! Yeah, good job! Good boy! Yes, you are! Good boy!
Street Smarts!
So, we all know that the Earth is made of, well, Earth.
And water. And what about plants? And rocks?
But what is the moon made out of? I have these kids here to help me find out.
Craters. Lots of gray stuff. Dirt. White grass.
I think it is made of mozzarella or Parmesan cheese. And if I were to go to the moon, I would be sitting there all day long eating cheese.
Do you think you'd get sick of the cheese?
Yes, I would.
Here's a question from Evan.
Why does the moon light at night, but not so much during the day?
Well, Evan, I found the answer on the website for NASA. They're people who explore space.
This is the moon at night. It's brightly lit up. And this is it during the day. You're right, Evan. It's not so bright now. But why?
I think this calls for...
The experiment! The NASA article suggested this experiment. Pretend this is the sun, and this mirror is the moon.
There's a lot of light, so when I put it over here...
We can still see the mirror. It just doesn't stand out a lot against the bright daytime sky. But when it's night, my mirror looks bright against the dark sky. Whether it's day or night, we can see the moon because it reflects the light from the sun. The moon doesn't make any light of its own. Look, if I turn the sun off, no more shiny moon.
So the moon has another disappearing trick up its sleeve, as Marissa points out.
Why sometimes the moon is full, or sometimes the moon is not full?
Marissa, that's a very challenging question, and the answer calls for...
My Great Challenge!
Okay, contestants, let's take a look at the phases of the moon.
Marissa is right. Here the moon is full. You can see all of it. But now, watch that moon start to disappear. It gets dark on one side, and it keeps getting darker a little more each night until you can only see half the moon. Eventually, you can only see a sliver of it, until it looks like a giant toenail clipping.
I hope you don't leave those under your bed. Moms hate that. Well, at least mine does.
Yeah, mine hates that too.
Anyway, finally it reaches the new moon stage. That's when we can't see it at all. Then, it gradually reappears, until it's the full moon again.
That's my favorite phase, could you tell?
Yeah.
And it's also my signal to start this challenge.
You're gonna wear these way cool hats! Yay! Here comes the sun. Now, you are the Earth and you are the moon. Your job is to find the new moon, which is the one that disappears. Go!
Marissa, the challengers are bending their brains to figure out the answer to your question. Why is the moon full sometimes, and not full at other times? Team number 1 seems to be having trouble figuring it out. I guess they've got a lot on their minds. Get it?
Slower.
faster. Here, there. Can't really see the moon when it's there.
Yes, you're correct. When the moon is between the sun and the earth like that, that's when you can't see the moon as well.
That's because the sun isn't shining on the side of the moon you can see.
Now, the second part of the challenge is for you to find the full moon. Go.
Now,
Correct. As you see, now the earth is between the moon and the sun, and the moon is fully lit.
That's because the sun is shining on the side of the moon that you can see.
You guys took 1 minute and 50 seconds to complete the challenge. Here comes the sun again. Okay, team number 2, now it's your turn. You're trying to find the new moon, which is when you can't see it. Are you ready?
Yep.
Okay, go.
Can team number 2 figure it out faster than team number 1?
There. You're correct. As you see, the moon is between the sun and the earth, and now you can't see the moon. So now you're trying to find the full moon. Are you ready?
Yep.
Okay, go.
The clock is ticking. If they can do it on their first try, they'll win this challenge.
There. Correct again. As you see, now the earth is between the sun and the moon, making the moon full. That was amazing. You guys did it in 17 seconds.
Yahoo! Yeah!
Congratulations. The winner of the challenge is team number 2.
Yahoo!
Thomas, you did it really fast. Why did it come so easily to you?
I knew that when all the light would be on it, it would be the full moon. And that when none of the light would be on it, it would be the new moon.
Did you learn that in school, or where did you learn?
Well, I don't remember actually.
You just knew, because you're a genius.
Kind of.
Why do people say the moon tastes like cheese?
The short answer is because they've never tasted moon rocks, which don't taste anything like cheese.
The moon made out of cheese? That would be awesome! In the 17th century, someone noticed the moon looked like green cheese. People joked around a lot about it being cheese. Apparently people are easily tricked because it caught on quite quick that the moon was made of Gouda, feta, cheddar, Swiss cheese. Unfortunately, it's none of these.
Why do wolves howl at the moon?
That's a really interesting question. Let's take a look at some wolves howling.
Wolves howl a lot. They even howl in the daytime. I checked, and wolves are more active on nights when the moon is bright, since, just like with us, it helps them see. And the more active they are, the more they howl. So it's not that they are howling at the moon. It's just that when the moon is bright, they're most likely to be going out doing all the things that wolves like to do. Like howling.
Wolves hold their head up high when they howl, which is why if they're howling when the moon is out, it looks like they're howling at the moon. But speaking of wolves and full moons...
Does the moon turn people into werewolves?
The Flat Earth Corner!
Does the moon turn people into werewolves? Well, as everyone in medieval Europe knows, duh, of course it does. I'm actually getting as hungry as a wolf. I really could use some moon cheese. Strange. That one didn't sound like my stomach. Werewolf! Again! People used to believe that the full moon turned people into werewolves. But the truth is, there's no such thing as werewolves, except in movies. But that doesn't mean you have to tell your little brother or sister. Speaking of weird movie ideas about the moon, check this out.
The full moon is the brightest object in the night sky. So it's no wonder that it pops up in so many myths, songs, and stories. and in this old movie. People have been dreaming about going to the moon for a long time, even if they didn't get all the details right.
So that's not exactly how it happened, but it brings me to my next question, which is from Steven.
I want to know who was the first man on the moon.
Well, it definitely wasn't this guy.
Or these guys.
But there really was a first man on the moon.
The first man on the moon is on board this rocket. He went a long time ago, in 1969. 2 other astronauts are with him in the rocket. It traveled about 400,000 kilometers. That's the same distance as going around the Earth 10 times. When they got there, one of the astronauts, Neil Armstrong, became the first person to walk on the moon and talk on the moon.
It's one small step for man, one giant leap for mankind.
Altogether, 12 people have been to the moon. They collected moon rocks and soil. And they also seem to spend a lot of time bobbing around. As Destiny has noticed,
Why do we float on air when we walk on the moon?
well, Destiny, walking on the moon feels a lot like walking on a trampoline because the moon has a lot less gravity than the Earth does. So we don't weigh as much on the moon as we do on Earth.
I was strolling on the moon one day in a merry, merry month of December. How May. Dum-de-dum-dum-dum. Dum-de-dum-dum-dum.
So if you weigh about 70 pounds on Earth, like me, then you probably weigh only about 12 pounds when you're on the moon. That's the same as, like when you were a baby. That's me. I'm so cute. I wasn't so bad when I was a baby either. Anyway, this gives me a good idea for my Do Try This at Home.
Uh-oh. Do try this at home.
To get a sense of how different it would be if you were on the moon, try this. Wait, I think I can do better. Let's try that again. Now you try. Are you ready? And jump! Good. If you were like most kids, you probably jumped between 1/4 meter and 1/2 meter.
But if you were on the moon, you'd be able to jump 6 times higher. That's about 3 meters. That's higher than most ceilings. That would be pretty cool.
Note to self, don't try this at home if your house is on the moon. Now here's a question about something that happens right here on Earth.
How does the moon control the waves?
The answer is pretty amazing.
Our sun's gravity pulls on the Earth, which is why the Earth circles the sun.
I'm heavy, so I've got a lot of gravity. Huh.
Earth's gravity pulls on the moon, which is why the moon circles us.
I've got some influence of my own.
But even while the Earth is pulling on the moon also affects the Earth.
You're not the only one with pull around here.
That blue is Earth's ocean. Because Earth is always spinning, the moon is constantly pulling at different parts of it.
That makes the tide or water level of the ocean higher in the parts of the Earth closest to the moon. There's also a high tide on the opposite side of the Earth, because the moon pulls harder on the Earth than on the water over there.
If you don't live near the ocean or have never been there and seen the tide come in, it's pretty amazing. Check this out.
This is the Bay of Fundy in Nova Scotia. It has the highest tides in the world. The difference between high and low tide here is almost 17 meters. That's the height of a 5-story building. And look, this turbine uses tides to create electricity. See the wheel turning? And some people have used the moon's tides to have fun. Like these people surfing on a tidal river in Great Britain. I say, this is jolly good. Yeah, hang 10, mate.
Well, the moon is pretty awesome. It's beautiful to look at, it's our closest neighbor, and it has a strong effect on our planet. So there's just one last thing we have to figure out, and that's the answer to the question that brought me on this lunar quest to begin with.
Why does the moon follow us?
So, Carl,
your big answer is... distance! Remember when I said astronauts traveled 400,000 kilometers to reach the moon? Well, that is very, very far away. But these buildings are really close.
When I walk down the street, I pass the houses and trees quite quickly. But the moon is so far away that it doesn't seem like you're walking past it.
And that's why it seems like the moon follows us. Actually, the moon has some traveling of its own to do, and I'll show you that right now.
If you stay in one spot and watch long enough, you'll see that during the night, the moon appears to travel far across the sky because the Earth is turning.
See you next time for more Finding Stuff Out. Later. Try to follow me now. I would sure love to go to the moon one day. What about you guys?
Yes! Because I love cheese.
Hi, and welcome to Finding Stuff Out. I came all the way up here to the International Space Station because of this question from Veronica.
Could kids go to space? I'd like to go.
I want to go too. So today, I'm gonna train to go to space with the help of some real astronauts. And by the end of the show, I'll be able to tell you how kids can go to space. Who's with me? Let's get some.
Would these kids like to go to space? Let's find out.
I'd like to go to space so that I could have no sense of direction whatsoever.
So I could be the first person to plant a tree on the moon.
So I could squeeze a bottle of water and just suck it up with my mouth, like that.
I would so I couldn't see the sun to discover the planets.
Because then I could meet an alien, see, I already practiced.
I want to be the first kid to breakdance on the moon.
I don't want to go to space because I might get dumb and take off my helmet.
Note to self, don't take your helmet off in space. Anyway, here's the next question. It's from Mia.
Where did astronauts get the idea to go in space?
The Flat Earth Corner! No one really knows who got the idea to go to space. But more than 200 years ago in Paris, Claude Ruggieri was the first person to try it.
Step right up, folks. This is your chance to see the very first space travel. With my rocket, I'm going to send this sheep into space.
Yikes! Good thing the sheep had a parachute. But Ruggieri had bigger and better plans.
Hey, you! I'll send you into outer space. Drats! The Paris police always spoiling my fun.
Fortunately, the police stopped him before he had time to send a kid up in the air. His astronauts only got about as high as an office building, which isn't anywhere near space. It was a start, though.
If astronauts weren't tied up in space, would they just float away?
The short answer is only if they're in space. Every object creates gravity, a force that can pull other objects towards it, sort of like a magnet. So really big objects, like Earth, have a lot of gravitational force. So when you're here on the planet...
Hey, get back here.
Gravity pulls you back to Earth. But the further away you get, the weaker Earth's gravitational pull is until it can't reach you at all. So yes, Sabrina, astronauts would just float away if they weren't tied to their spaceship during spacewalks.
Gravity can't get me when I'm traveling out in space. It can't pull my pants down or put wrinkles on my face. 'Cause when I am in the cosmos, far from things with gravity, I can float around my spaceship free and nothing pulls on me.
Here's a question from Andrew.
How do astronauts train for zero gravity?
You're probably wondering why I'm upside down. In zero gravity, it can feel like blood is rushing to your head. To find out more, I'm calling my friend Jeremy in Houston, who's a real astronaut in training.
Hi, Harrison. I think there might be something wrong with your camera.
Oh no, I'm not actually upside down. Here.
Oh, I see. You're just practicing.
Yes.
Well, great. That's a great way to practice. In fact, sometimes I practice what it's going to be like in microgravity one day.
Do you actually practice like that, though?
Well, I have, yeah, but not usually. We have better ways of doing it. You should come try it sometime.
So how do real astronauts do it?
Well, we have this really cool airplane, and you get in this airplane and it flies up into the sky, and then you're just sitting on the floor, and it does this roller coaster motion, goes down like this, and while it's diving down, you're in zero gravity. You're floating just like you're in space, and it is a ton of fun. You can fly all over the airplane, you can do flips, you can tackle your buddies. It's just a really great time, but most importantly, you get to experience what it's going to be like when you're in space.
I found some video of you training in a swimming pool. What's that all about?
Right over here, I've got what we use to keep ourselves alive when we're in the pool. I've got a spacesuit here. And this spacesuit, if I were to put you in it, weighs about 200 to 300 kilograms. So it's really hard to train with here on Earth. It's very, very heavy. But if we put it underwater, we can make it float. And that's how we simulate being in space and working in this spacesuit. It's a very cool spacesuit, allows you to do a really cool job out in the vacuum of space outside the space station, but it's also very hard to work in because it's big and bulky. Look at the size of these gloves. Imagine doing fine tasks with this.
Yeah, you have like nubby fingers and stuff, it looks like too.
Yeah. You know what else is important to realize is you can't scratch your nose. I think it's worth it. Can you imagine the view of our planet from space? Small price to pay.
Wow, well, being an astronaut must be pretty amazing. Thanks so much for helping me find stuff out.
Hey, my pleasure, Harrison. You take care. So long.
Sounds kind of hard to float around in zero gravity on a spaceship. To find out how, it's time for... My Great Challenge! Today, our challengers are Commander Joseph and Commander Malinka. Are you ready to experience zero gravity?
Yes, I am.
Me too.
All right, well, today you won't be leaving the planet, but you'll definitely be like you're living out on a space station where there's no gravity. You'll be strapped into this simulator. And your challenge is to bounce around, grab these Energizer cells right here, and then get all the way over to that satellite and screw them in. The one that does this the fastest will be the winner. Sound good?
Yes.
Commander Joseph, you're up first.
Yes, sir. Good luck in space.
Thank you, Commander Malinka.
Go! Zero gravity is sort of like being in a bouncy castle. Oh, missing them. It's as difficult as being in real zero gravity. He's got one. Now he has to get it to the satellite. Oh, he dropped it. In real outer space, that energy cell would be floating away forever.
To the satellite.
Quick! The satellite is losing power! Getting close. Does he have one? He has one.
He has one?
Yeah, one's in. Joseph's really speeding up, unless he drops this one, too. Yes! Oh, there, he almost has it. He just has to get it in. He's got it! 1 minute 25 is the time to beat.
I'm ready to win.
Go!
The yellow one. Good start.
Yeah, she has a good start. Hey, Malinka, don't just float around. You've got a race to win. Hurry, your spacecraft is losing power. Oh, she has it right away. Oh, does she have it? Yes. Wow, Malinka's fast. Oh, she almost missed it, though. Malinka's only got a few seconds left to beat Joseph's time.
Oh, she has.
Wow, she's going really fast. And does she have number 2?
Yes.
Yeah, she has it. Okay, Commanders, here are your results. Commander Joseph, your time was 1 minute and 25 seconds. And Commander Malinka, your time was 1 minute and 20 seconds. You're the winner.
Yes!
Okay, so how did it feel to be an astronaut and bouncing up and down and stuff?
It was really fun. I felt like I was wearing a big marshmallow costume.
And what about you? What did it feel like?
I felt like a floating pumpkin.
Right, because of the orange suit?
Yeah.
Well, thanks for being on my show and thanks for helping me find stuff out.
You're welcome.
My next question is from Cassandra.
If I would be able to touch the sky, would it stop or would it continue?
I checked the answer, and the atmosphere around the Earth does end eventually. Astronauts have to blast through it to go to space. But space itself goes on forever. There's no end to it. How can that be? It must have an end. But if it did end, what's outside of space? There's nothing in space but space. Head getting warm, spatial overload. Ah! You're gonna make my head explode. Scientists think that space goes on forever and ever and ever. Kind of scares me to think about that. So let's think about something else.
Who was the first astronaut in space?
Well, we know it wasn't Ruggieri sheep. But I checked, and here's what I found out. The first astronauts to go up into space and safely come back.
Excuse me?
Were actually 2 Russian dogs who were sent up in a test program to make sure it was safe for humans to go into space.
Sweet. Decent.
But if you mean the first human, that was Yuri Gagarin, a cosmonaut. That's a Russian word for astronaut. More than 50 years ago, in 1961, Gagarin spent 108 minutes in outer space, traveling around the Earth once. Since then, more than 500 people have been to space, some for more than a year. Zero gravity makes me sleepy. Here's a question about that.
How do you sleep in space?
I found out that astronauts sleep in sleeping bags attached to the wall. That's so the astronauts don't float away. Floating away in your sleep would be really bad. I thought I'd try sleeping their way, but it isn't very comfortable. At least, not here on Earth. But I found a video of astronaut Chris Hadfield explaining how it works.
I'm in my super comfy Russian full-length pajamas. Nice for when you have to get up in the middle of the night, and ready to go to bed. I'll show you where I sleep.
Astronaut Chris Hadfield is the first Canadian to walk in space and to command the International Space Station. On his last mission, he went to bed 145 times.
This is my sleep station, my sleep pod. This is where I spend up to 8 hours every day.
Look what happens when astronauts squeeze a rag. Weird. Everything is just a little bit different in space, like cutting your nails over an air duct that sucks them in, so they don't go flying everywhere. Getting a haircut with a vacuum hose on the cutter, and especially washing your hair, as astronaut Karen Nyberg shows us.
What I like to do is start by just putting some hot water, squirting it onto my scalp. Sometimes the water gets away from you, and you try and catch as much as you can. Then I just work the water up through to the ends of my hair. And I take my no-rinse shampoo and squirt it also on the scalp, just a little bit, and rub it in. Again, kind of working it out to the ends.
How do astronauts get their food?
Whoa! The International Space Station! I'm here at the Canadian Space Agency with Danielle, who's a mission controller.
Hi.
Hey, so how do astronauts get their food?
Well, there are 6 people living on the real space station, and every few months we launch a spacecraft with food in it. And for some of them, they go right next to the space station, and we have to grab them with a Canadarm. And that's gonna be your mission today.
Awesome! So, do real astronauts train here?
Yes, they do, and you're gonna be using the same simulator.
Whoa!
But first, let's find out about the food that you'll be delivering.
For sure.
Well, this is Natalie, our space food expert, and this is Harrison, our delivery boy.
Nice to meet you.
Nice to meet you too. Well, I'm gonna go and set up the simulator.
All right.
Are you hungry?
Whoa! Look at all this food. Oh, some of it doesn't look very good. It looks kind of weird. Like, what is this?
This is macaroni and cheese. So this is just like the macaroni and cheese you have on Earth, except the water's been taken out of it. So when an astronaut's ready to eat it, all he does is put hot water right here, wait 10 to 15 minutes, like it says on the instructions.
Right.
And then you cut this open, and you can just eat it out of the package,
And
like out of a bowl.
It'll taste as good as it does on Earth?
It'll be delicious.
Nice. So what can astronauts not eat in space?
Any food that makes crumbs.
Oh, so they can't eat like cookies?
Well, they can eat some cookies as long as those cookies don't make crumbs. And this is an example of cookies that they could eat in space. These are actually crackers, but they're bite-sized, so you could put them in your mouth in
Right.
one bite and you won't make any crumbs.
So what's the problem with crumbs floating around in space, though?
They can get into equipment and that can damage the equipment, which can be a problem. Or they can get into an astronaut's eye, not very comfortable. Or they can breathe them in and get them into their lungs, which can be a problem too. And we don't want them to choke.
Right, that'd be bad.
Yeah.
So what other foods can they not eat in space?
They don't normally eat fresh fruit and vegetables. There's not a lot of refrigeration up there, so there's nowhere to keep the fruit and vegetables fresh. So we have to send them dried fruit and vegetables. So for example, this is dried cranberries.
Right.
It's packaged in packages like this, or it can be in a bar. For example, this is a fruit bar.
Yeah.
And that's another way to get fruit to the astronauts.
Nice.
But sometimes astronauts might want a little snack.
Like, what about these chocolates? They get chocolate in space?
They do.
Nice.
So that's cranberries covered in chocolate.
These are out of this world.
They're pretty good, very popular. So I think Danielle's waiting for you to deliver some food to some hungry astronauts.
Oh, all right. Let's deliver some food.
Okay, this is a model of the end of the Canadarm. You're gonna use that to go and grab the spacecraft by this bin that we see right here and here. So you're gonna do that using these 2 hand controllers or joysticks.
Danielle showed me how to work the simulator.
Left, right.
I have to move the Canadarm so that the end locks onto the pin on the shuttle. Then the arm can dock to the space station.
Wow, I think I'm gonna be good at this because of the years of experience of video games I have.
Well, let's see.
How many tries do I get?
Since we're only training, as many as you want. In real life, you only get 1 shot.
1 shot. Let's see if I can do it in 1 try.
Okay, you're ready to go.
There we go.
Very good.
Move it up. Okay. Wow. Are astronauts normally good at this?
Well, some of them are. The ones that used to be fighter pilots tend to be really good. But then there's some that are doctors and scientists and really never had time to play video games. So you might actually be better than them.
Whoa. Hopefully. Getting close. Whoa, okay. I'm almost there.
You're doing really well. You're getting closer.
Whoa.
Standing by for grapple confirmation. Robotic arm finishing closing in.
Now. Did it work? Did I get, yeah.
Dragon confirmed in place and docked to the International Space Station at the Harmony node.
I got it.
Well, mission accomplished. Now the astronauts can eat.
I'm like a real astronaut now, sort of.
We could make an astronaut out of you, I think.
Well, thanks for being on my show. Do you think I could really be an astronaut one day?
Sure. If you apply yourself, get a good education, and you definitely have the video game part down, so good luck.
Thanks. This is awesome.
Hey, I've got a call. It's from Jeremy.
Hey, Harrison. Good to see you again. They told me you were at the Canadian Space Agency training with him on Canadarm2.
Yeah, they said that I could apply to be an astronaut someday, but is it possible for a kid like me to go to space right now?
Well, not right now, Harrison, but one day.
Oh, I guess I can answer the question that started us off.
Could kids go to space? I'd like to go.
The big answer is... apparently we can't.
No, hang on, Harrison. That's not it at all.
But I thought you said you couldn't take kids with you.
That's partially correct. We're not taking kids to space right now. But one day, when those kids get older, they can definitely be astronauts, and we're gonna need astronauts to fly in space. There are amazing things happening in space right now.
Liftoff of Falcon 9.
Dragon is sensed for stage acceleration.
In fact, for the first time in history, commercial companies are building new rockets to take people to space. And more people are going to be flying in space in your lifetime. In fact, I think one day it's going to be kids who are about 7, 10 years old that'll be the first humans to walk on Mars.
Whoa, that's awesome. So I guess the astronauts of the future are kids today.
Absolutely. You know what you have to do if you want to be an astronaut? You just have to do your very best. That's all you have to do. Find out what you love to do in life, follow that passion for the things you love, and just do your best.
Awesome. Well, thanks for being on my show. I'm gonna go train right now. On-the-job training, there's nothing like it. But being in space makes me hungry. Time for a space snack. Aw, pesky helmet. Uh-oh. Note to self. Don't take helmet off in space. Thanks for watching Finding Stuff Out.
Hi, welcome to Finding Stuff Out. I'm just getting over a sore throat, and gargling with salt water seems to help. It's like having my own little ocean. Speaking of that, here's a question from Vito.
Are sea monsters real?
The Flat Earth Corner! Are sea monsters real? Well, landlubber, if you're a 16th century sea dog like me, you know they are. I haven't seen one myself, but my best friend's captain's daughter has, like the Kraken. A kraken wraps its giant tentacles around a ship and eats every last sailor down to the bone. Then there's the Greenland sea serpent, its ferocious head taller than a ship's crow's nest. And the sea orb that can gobble up an entire vessel and its crew. Scary enough to have you running for the poop deck. Yes, the sea is full of monsters. Just ask my first mate's brother's neighbor's midshipman who knows somebody that got scuppered up by one. Ah! Hundreds of years ago, sailors saw strange things in the sea and thought that they were sea monsters.
Today we know that the Kraken was probably just a giant squid, but pictures of a living giant squid were taken only a few years ago. The ocean is so big.
We still don't know all the creatures that live down there, but I can confirm for you, Vito, that there is at least one sea monster. Today, I'm gonna answer all your questions about the ocean, and by the end of the show, I'll show you that monster. Street Smarts. Whenever I'm at the sea aquarium, there's always one question I want to find out. So, do you guys think that sea monsters are real?
No. No. Yes. Not really.
So, do you think sea monsters are real?
No.
What about your bathtub? There's sea monsters in there, right?
No.
If they did exist, what do you think they would look like?
Well, it could be green or maybe gray from the water it's been in and the pollution.
A big blob, yeah.
A big blob?
A dark color, like green or black, and have sharp teeth.
Sharp teeth. That's pretty scary. So what do you think a sea monster would sound like? That's pretty good. Yep. Nice.
Personally, I think the sea monster would look something like this. Scary. Time for another question.
Why is the ocean salty?
The short answer is because there's salt in it. I kid. But you're probably wondering how the salt got in there. And it turns out the ocean doesn't start out salty. Here's what I found out. Beautiful clear spring water flows down from the lakes and the rivers down to the ocean. I like to think of it as clear juice.
On its trip to the ocean, water moves over soil and rocks, which have salt in them. The water drags the salt into the ocean.
Say this glass of water was the ocean. Then it has this much salt in it. That might not sound like a lot, but if you take all the salt out of the ocean, it will cover the earth up to the height of a 40-story building.
Wow.
With all the salt in this water, you might be wondering, who'd drink this stuff? But that's exactly what Dakota wants to find out.
How do fish drink?
To find out more about fish and how they drink, please welcome my special guest biologist, Dr. Adam Brown.
Hey, Arson.
Hi.
How you doing?
Good.
So I hear you want to know how fish drink.
Yeah, I asked my fish how he drank, but he just said...
So I guess you don't really speak fish then.
No, not really. So how do fish drink? Is it out of a straw or a glass?
Well, actually, fish don't really drink in the same way that we do.
Okay.
Mostly because they're bathing in water, right? So water either moves in or out of them on its own, and that's a process that we call osmosis.
Okay.
Which basically means that water tends to move towards areas that are saltier. And so, depending on where the fish will live in the world, it'll either always have to take on water or always have to get rid of water.
So can you show us how all this works?
Well, yeah, exactly. I've got a great example for this using a simple potato.
The experiment.
So what I've done is I've cut up some potato slices here that I'm going to be our sort of pretend fish.
Okay.
And I'm going to put these pretend fish into the two types of water that we have on Earth, salt water and fresh water.
Okay.
Right?
I think I have just the thing.
Okay.
That's not it. Oh, not that again. Oh, here it is. Okay. So we can have potato fish.
All right, let's make some potato fish here.
It's a new species of fish called potato fish.
Yeah. There we go. Potato fish
Number
one would be in the ocean.
Okay.
And potato fish number two.
He gets to be in fresh water.
That's right. Okay, so let's put the salt water here on the ocean fish.
Okay.
Let's put the fresh water here in the lake or the river fish.
Okay. So what's going to happen to these potato fish?
Well, remember I said that water moves in and out of organisms on its own based on osmosis, and it always goes to where it's saltier, right? Well, here what we have is a potato fish in salty water. So that potato fish is less salty than the water around it, meaning the water is going to move out of the potato fish into the salt water. And here what we have is the potato fish is in fresh water. It is actually saltier than the water around it.
So the water's going to
The water's going to move in. That's what we expect to happen.
So what you're saying is...
If the saltwater fish didn't drink, it would shrivel up.
Ah, there's the stuff.
And freshwater fish absorb all the water that they need. So if they drank any more, they'd pee a lot.
Well, yeah, that's exactly right. Either they pee a lot or they're going to end up exploding with all of that water in there.
So how are the potatoes doing?
Well, they're not quite ready. We still have to wait a little.
I hate waiting. I have an idea. That's better.
Okay, well, we should be just about ready by now. Let's have a look and see what's happened. So we take our freshwater fish here and our saltwater fish here, and they're quite different from one another. I don't know if you can see it. This saltwater fish is definitely much smaller than the freshwater fish now, and it's squishier and kind of gross feeling. I don't know if you want to touch that. I wouldn't, but now that you do. So this one's softer.
It's like mushy and that one's not.
This one's firm. So this has confirmed what we expected to happen, is that because this freshwater fish is saltier than the water has moved in, and it got bigger and it got firm. Whereas here, the saltwater fish is less salty than the water around it. So the water's moved out and it's gotten all small and squishy and slimy.
So you think with all the fish in the ocean, they would drink it all. Here's another question.
How big is the ocean?
Let's see. Most of the Earth is covered by water. Ocean rhymes with potion. Circumference of the Earth equals 40,000 kilometers. Carry the sphere. Remainder. You're gonna make my head explode! I'm glad Adam is here to answer, because as far as I know, the ocean is ginormous big. Is that right, Adam?
That's right, it is pretty ginormous. And I can see it's hard to get your head around sometimes, given what you just went through. But I've got a picture here I brought that might help illustrate this. Have a look at this. And what we have here is...
the carpet.
Well, it's hard to tell what it is, but do you see this pale blue dot right here?
Oh, that thing?
That's the Earth.
What?
Yep. That's the Earth taken from 6 billion kilometers away. And from that distance, we call it the pale blue dot. Well, because it's a pale blue dot. But why do you think that is? Because of the water.
Oh, okay.
Right. So even when we look at the Earth from a little bit closer, like here, you start to recognize it a bit more.
Yeah.
And we call it the blue planet from this distance, but you can really see the oceans here. And you can even see that there's another form of water on the Earth, and you can see the clouds, right? And they're made of water too. So when you look at it on this level, you can really see that there's more than twice as much water than there is land on Earth.
Wow.
So there's a lot.
The ocean is so big that if we divided it up into swimming pools, then it would be enough water for everyone on Earth to have 75,000 pools each. Sweet, right?
I'd tell you how many toilets it equals, but it's in the quadrillions, and you don't want to think about diving into that. Here's another question.
Why does water make stuff float?
So we know that rocks sink and feathers float, but what about huge ships? They float, and it's a good thing they do, because they transport things all around the world for us. So why do things float, Adam?
Yeah, well, that's a really good question. And to help illustrate the answer, I'm going to use these two familiar objects. Relatively similar in size, even though one is a bit bigger than the other. We have our lemon and the citrus cousin, the lime. So what I'm going to do, put the lemon in the water, what happens?
It floats.
It floats. So we're going to put the smaller one in, and what do you expect to happen?
It should float, or not.
But it doesn't. So what's happening here? Well, the answer lies in the word called density. These objects are different densities, which essentially means that they have different amounts of air inside them. So in an object that has more air inside of it, it'll be less dense, and so it'll float. And so the opposite being that if it has less air inside, it's more dense, and then what happens?
It sinks like the lime. Who knew? Well, I guess you did because you just showed me. But I think we should put all this to the test in... My Great Challenge! Today, my great challengers are Cameron and Benji. Woo! Okay, today your great challenge is to take a ball of plasticine like this and try to make it float. Another thing you have to do is once you have it floating is to get it from one end of the pool to the other without using your hands. But you have these fans to help you.
Can we make the ball of plasticine any shape we want?
Well, yeah, actually, whatever floats your boat.
Okay, are you ready? Yeah! Get set, go!
Benji's flattening his plasticine, and Cameron's making his round.
Give it a shot.
Ah, it looks like Cameron's plans were sunk.
So that one didn't work.
Are they getting the right idea here?
Well, it looks like they're on the right track. Remember we were talking about the limes before and the lemons, and that was sort of a question of buoyancy and how much air is inside? Well, this is a bit of a different situation. It's more like the object and the water are pushing against each other. So what you want to do is you want to have like a push of war rather than a tug of war, and you want the water to win, so to push it up to the surface. And,
Sounds great.
Getting there, I think, though. I guess as well, you want the water to stay under the plasticine and not to get on top of it, too. That would make a big difference.
Cameron, trying again. Watch out for the Kraken. Benji testing out his plasticine.
Maybe you could think like a boat or a canoe, right? Because they have edges that come up so that the water doesn't come in as well.
Of course, you can't have holes in your boat either.
Yeah, well, that's right.
That's what I'm working on.
So why do you think they're having such a hard time getting their plasticine to float?
Well, I think one of the reasons is because you chose a very difficult challenge today, but really I think it's a question of making sure that the weight of the boat spreads itself out as much as possible over the surface of the water, and that's really tricky to do. That's a nice flat pancake.
Yeah.
Place it really gently.
Oops. Just water got on top of it, right?
That's right. Okay, we're back to the canoe form over here. If you can try and make a lily pad here,
maybe
that might be a good strategy. And you're gonna have to put that in the water really carefully, though.
Looks like a pan almost.
Looks
I
like
think
a
he's
raft.
getting really close there. Let's see.
And it floats.
Oh, he has it.
Look at it go!
No.
Cameron's boat floats because it weighs less than the water it pushes out of the way.
Looks like the lily pad was successful.
Looks like Cameron's our winner.
Yes.
Congratulations.
Right.
Uh-oh. Do try this at home.
Okay, so here's an experiment you can do at home. All you have to have is 2 glasses of fresh tap water. Then, with one of the glasses of the fresh tap water, put some salt in it and stir it up. And now, since salt water is more buoyant than fresh water, you take some eggs, you put the egg in the fresh water, it sinks, and in the salt water, it floats. Now it's time for another question. This one's from James.
What's the deepest anyone has ever gone into an abyss?
James, I looked up what an abyss actually is, and it turns out it's a really deep pit in the ocean. It's so deep, they gave it a really deep name. It's called Challenger Deep.
If you took the tallest mountain on Earth, Mount Everest, and threw it into Challenger Deep, it would still be covered by like 3 Eiffel Towers of water.
Oh.
The deepest anyone has ever gone is when 2 guys went to the bottom of Challenger Deep. Did you ever dive down deep in a pool and your head started to feel squeezed? That's pressure from all the water above you. In the deep ocean, the pressure is so strong, we need to go down in submarines or our heads would implode.
That means it gets smaller. Like this. Check out these weird creatures that live down there, but don't implode.
These fish have to have some pretty cool adaptations to survive there. That means their bodies have changed to allow them to live down there.
Because it's dark, some of them have bigger eyes,
or can even make their own light. They're totally freaky looking.
But not as scary as this next question from David.
Why do sharks die if they stop moving?
Sharks? They're scary, especially with this music. So to find out the answer to your question, David, I'm gonna meet one. I'm so scared.
But at least I didn't actually have to swim with one, like marine specialist Nicole Cant does all the time at the aquarium.
So Nicole, what are you gonna do today?
I'm gonna go for a swim with these sharks.
But they're sharks!
Well, yeah, they're not as scary as everybody thinks they are. What is the scariest part of their body to you, Harrison?
Well, they're sharks and they have big teeth and they'll eat you and they're gonna hurt you.
Okay, let's talk about the teeth for a second. Granted, sharks have some pretty impressive chompers, but they used to be a lot bigger. Do you want to see a tooth?
Sure.
Okay. This is actually a mold of the biggest shark's tooth we've ever found. It's about as big as your head.
It is as big as my head, pretty much.
And this was called the mega-tooth shark, but it's been extinct for a really long time. Nowadays, they have much smaller teeth. In fact, this is a real black-tip reef shark tooth from the sharks I'm gonna go swimming with.
So small.
Yeah. And it's perfectly designed for eating fish, not people.
That's good. So let's answer David's question. Do sharks die if they stop moving?
Some of them could. The black-tip reef sharks in here, the big ones, if they stop moving, they're not passing water over their gills, so they're not getting any oxygen. Basically, they stop breathing. But some sharks can actually do all of that and pass that water over their gills even while they're staying still, so they can hang out at the bottom and have a little bit of a rest.
But They're still really scary. What if they come to my house and eat me?
They're not gonna do that. Are you a sick or dying fish?
Definitely not.
Then they're not gonna eat you. These are top predators out in the ocean, but they have a really important job to do in their ecosystem. They eat the sick, the injured, or the dying prey items. And by doing that, they actually help clean those animals out so they don't spread their diseases to the rest of the population. In fact, they're keeping fish populations really healthy in the ocean.
Well, then I'm not getting sick. I'm gonna go take some vitamins and eat some broccoli.
All right, and I'm gonna go for a swim.
Oh, well then, I'll save the broccoli for later.
Good luck, Nicole, but don't say I didn't warn you. So Nicole told me that sharks are at the top of the food chain in the ocean, but there's something at the bottom of the food chain that Nicole says is only about this big, but it's just as important: phytoplankton. And this phytoplankton stuff is a pretty big deal too. There are more than 5,000 species of it. Look at these! You know what's amazing? Phytoplankton produce half the oxygen for the whole world.
Here's a question from Angelina.
What do oceans do?
You mean like on the weekend, or do you mean why is it there? I think the question is, what doesn't it do?
It's a highway for us to transport stuff around the world. It gives us food to eat and rainwater for us to drink and use to grow crops. We need the ocean to survive, and it's home to more species than we can even count.
Let me catch my breath, and then I'll be able to answer the question that you've all been waiting for.
Are sea monsters real?
Well, Vito, the big answer is, I'm gonna show you one. There's no real proof that sea or lake monsters like the Loch Ness Monster exist.
And the Kraken was probably just a giant squid. But just because those monsters aren't real, it doesn't make the ocean safe.
But there is something really scary in the ocean, and I'm about to reveal what it is right now.
There's a monster in the sea. Away, yo! There's a monster in the sea.
You better not go.
It's spreading oil on the waves
for 20,000 leagues.
And garbage in the deep.
Davy Jones low.
It's got billions of teeth
and billions of arms.
It's eating all the fish and it's causing lots of harm. But it doesn't look like these creepy beasts, 'cause the monster in the sea is you and me. 'Cause the monster in the sea is you and me. Yes, the monster in the sea is you and me.
For a long time, humans have used the ocean as a bottomless supermarket and garbage dump. Not a good combination.
Experts say that 1 out of every 4 species of fish is being caught faster than it can reproduce and make new fish.
Fortunately, a lot of people, including kids, are realizing that we need to be careful with the ocean. We need to protect it if we want it and us to stay healthy and monster-free. And if we want a place to surf. Thanks for helping me find stuff out. Gotta go hang 10. Surf's up! Woo! Hi, welcome to Finding Stuff Out. The show is simple. You ask, I find out. It's not rocket science, unless you ask a question about rockets. Then it is. Here's today's first question.
It's from Joy.
How come weather just changes to other weather, like first it's hot, then it's cold?
Yeah, what gives? Weather's always changing and I don't know why. But by the end of the show, I'll have the answer to your question. Along the way though, there'll be tornadoes, snow, hail, and if my dad doesn't fix the washing machine soon, maybe even a flood. I'm going to start the investigation with the question from Hanifa.
How could the sun be out in winter when it's cold?
Yeah, come on, son. Either you're hot or you're not. Pick a side. Pretend this light bulb is the sun. Now, lucky for you guys, I did some research on the subject. Now pretend this is the Earth, us. The Earth orbits around the sun.
The sun feels hotter in the summer because the part of the Earth you live on is tilted toward the sun. 6 months later, when the Earth has moved around to the other part of the sun, the part you live on is tilted away from the sun, so we can still see it. but we're not getting the full effects of the sun's rays, so it's not as hot. Next question.
How many kinds of snowflakes are there?
How many different ones? Let's see. They say no two snowflakes are alike. And they're only this big. I wonder how many fit in a teaspoon. Must be hundreds. But when it snows, there's so many of these, you need a shovel to clear a path. That must be millions. And then you need a snowplow to clear your streets. There must be billions, or trillions, or bajillions, or gazillions, or whatever they call a number that high, and...
You're gonna make my head explode!
I don't know if bajillion's a number, but there must be a bajillion different snowflakes out there. But seriously, nobody knows how many different snowflakes there are. But I can show you some of them up close with my super zoom-o-matic.
Check out these snowflakes. They all sort of have 6 sides. Weird. I'm not sure if they're different or the same though. So let's see.
Different, same. Oh wait, no, different. Forget it. I'd rather look at a bajillion snowflakes all at once than each flake one at a time, because that would mean snow day! Though I'm with Elizabeth on the next question.
Why can't it just be sunny all the time?
That would be amazing, Elizabeth. To figure it out, please welcome my special guest, TV weatherman, Frank Cavallaro.
Hey, Harrison, how's it going?
Hi, Frank. Welcome to my show.
Nice to be here.
Now, did you bring your thunder for the interview today?
No, but I got something else for you.
Oh.
Some snow.
Okay, so could we have sun all the time?
I don't think so, because there's always going to be some cloud cover around, so therefore it'll block the sun's rays.
So no permanent sun?
Actually, that's a good question. You know, there's going to be a time every year, I'm going to use the globe here, there's going to be a time every year for 6 months where the North Pole, as the Earth rotates, will have daylight for 6 months.
Well, I'm just going to move there.
No, hold on now. Doesn't mean it's going to be hot. But look at what happens 6 months later. The South Pole will get the sun, and the North Pole is dark for 6 months as the Earth rotates.
Living in darkness? I'll leave that to the mushrooms. Anyway, here's a question from Shakur.
My question is, why is there wind?
The short answer is 3 being chilly. But seriously, I found out that the sun causes wind. The sun heats up the land and the air, which causes hot air to rise. Then cold air zooms in to take its place. Hey, I should make a song about this. It could be a rap. Hit it!
Yo, hot air goes up, cold air goes down. That's when we feel wind on the ground. It blows around leaves and sticks and twigs. It even blows off my grandpa's wig. Land heats fast and water slow. That changes how the wind will blow. Yeah, wind will go just where it needs, 'cause air heats up at different speeds.
All this talk about wind takes my breath away. Hey, that reminds me, I can make my own wind. See? Wind. You can measure the direction and the speed of the wind using something called a windsock. Frank will show us.
Uh-oh. Do try this at home.
Here, I brought this sock for you, Frank.
We're not here to measure smell. We're here to measure wind.
Well, I think you can also do it with a paper bag, so you can try this at home. Here, show us.
Okay, let's try this. I'm going to use a fan in this paper bag. This is a light breeze. Anything over 10, 11 kilometers an hour is a light breeze. But watch what happens if we get a gust of strong winds.
Whoa, it opened right up.
And this could cause damage to branches, trees, roofs, and your hair.
Not my hair. Yeah.
Yeah, your hair. So Harrison, you may have noticed at airports and helipads, they have these windsocks there. You know what they do?
Yeah, are they those orange things, right? I don't know what they are, though, what they do, I mean.
Well, most planes will land and take off against the wind.
Okay. So that means?
That means that they look at the windsock, and that tells them which runway to use as they're approaching the airport.
So a windsock is the airport's version of our paper bag.
That's right.
So I guess if a plane is landing, they'd be facing that way, right?
That's right.
They'd come down. Okay, so what can kids use this bag for outside?
Well, you can actually go in your backyard and take out a bag on a windy day and put up the bag, and it'll tell you how strong the winds are.
And which direction,
and which direction. And if there's no wind, then look what happens to the bag. It just dies.
Well, Frank, I just thought of another thing you can do with the paper windsock.
What's that?
Well, if you blow it up with air, and then you can make thunder. Here's another question. It's from Ben.
Where do clouds come from?
I looked it up, Ben, and I made this animation to show you where clouds come from.
So these water vapors in the air grab onto a piece of dust. And when a billion of their buddies do the same thing, we start to see them together as a cloud. The air up there is colder, so the cold air causes the water to condense. Then these drops crowd together like it's a huge party and start bumping into each other. As the droplets bump together, they form bigger and bigger droplets, and then when they're too heavy to float in the sky, they fall as rain. Here's a question from Chloe.
How do weather people know if it's gonna be sunny or not?
The Flat Earth Corner!
How does a weatherman in ancient Babylon know if it's going to be sunny or not tomorrow? Astrology, of course. If I look up in the heavens, I can see that the moon is in Virgo, in the 4th house. Jupiter is rising. That means I predict you're going to get good news, win friends, and influence poultry. Also, it's going to be sunny and mild. Mars is activating my 2nd solar house. This can't be happening! Maybe I should have dissected a chicken instead. In ancient times, people used to use the stars and the planets to try to predict the weather. But it didn't always work out. So now we have high-tech equipment that helps us predict the weather accurately. Well, most of the time. Right, Frank?
Yeah.
I guess that's a sensitive topic for you. I mean, how do you predict the weather? Do you flip a coin?
No. We use radar, satellite, we have different data, computer models that show us the jet stream, the wind, systems that are developing. We put everything together, and that's how your forecast comes out.
How come with all this high-tech equipment, you still get the weather wrong sometimes?
Well, Harrison, you know, Mother Nature's always full of surprises. The weather can change drastically very quickly.
How can the weather change so fast?
Things happen. The winds change direction, brings in colder air, temperatures drop, then the warmer air comes in, temperature goes up. It happens.
Wouldn't you be able to see the wind changing directions and stuff with all your fancy high-tech equipment?
Most of the time we do, but there are exceptions to the case where sometimes the weather just changes drastically that the computer did not pick up. But we're getting a lot better. We now have long-range forecasts. We can tell you the weather 6, 7, 8 days down the road. But I got to tell you, it's tough to do the weather sometimes, but it's fun presenting it.
Well, let's see how hard Frank's job really is with...
My Great Challenge!
Today, my contestants are Justin and Samantha. So today, you're going to be using your knowledge of wind, clouds, and forecasting to become TV weather forecasters. Think you can do it?
Yeah.
Okay then, Frank, please tell us how you do your job on TV.
Okay, guys, follow me. So this is where it all happens, guys.
It's all green in here.
Frank says he stands in front of a green wall when he presents the weather on TV. That's because there's a technical process that takes all the green out of the picture so he can put any kind of background behind us. Like this, or if you're a TV weather person, a map.
This is a clicker, by the way. Every time I press on this, a different map goes on. It could be a radar, a satellite, whatever I want to show. This advances my map, so it's all computerized.
So let's show the kids at home. So they see a map behind us right now, right?
That's right. They see a map, and when I click, the map will change. And you point.
Okay, let's do the challenge. Here's a map of the world. I'm going to be telling you different weather conditions, and your mission is to try and predict the weather and where it will occur. Now, there are 5 different weather icons: sun, snow, rain, cloud, and wind.
And I'll be asking you where to place the specific icon to a corresponding city. But here's the catch. The viewers at home will see the map. You won't see the map. You're going to have to use that monitor.
It's just like how Frank does his weather forecast. Your goal is to make as few mistakes as possible.
Okay, Samantha, you're up first. Justin, you can go downstairs and have some milk and cookies with my mom.
Yes, I got the fresh ones.
Leave some for us, though.
Maybe.
Okay, are you ready?
Yeah.
Okay, first question. Water droplets have formed giant heavy clouds over London. What's going to happen?
Oh, Samantha's going for the rain icon. Not wasting any time.
Yeah, that's it. Good job. Okay.
Next question. The hot air over Thunder Bay is rising and cold air is moving in. Go.
Samantha's grabbed the wind icon. Oh, she's close. Not quite. Yes, she's got it.
Okay. Treble cone is in the southern hemisphere, and it's July.
Well, Samantha's found the southern hemisphere, but can't seem to locate treble cone. And is that the right icon?
No,
that's not it.
Not right.
That one's a little hard.
What happens in the northern hemisphere in July?
It becomes hot.
What happens in the southern hemisphere in July?
It becomes cold. Oh.
There you go.
That's correct. It's snowing.
Okay. Water vapor is condensing over Beijing. Go ahead.
Samantha's going for the rain icon again.
No.
I'll read the question again. Water vapor is condensing over Beijing. What's happening?
Clouds.
There you go.
There you go. Perfect. And that's it. Okay, Samantha, you're done. We'll send you downstairs for some milk and cookies, and now we'll bring Justin up and see how he does. Okay, Justin, now you're up. The first question is, water droplets have formed giant heavy clouds over London. What's going to happen?
Justin wastes no time in grabbing the rain icon.
That's right.
Next question. The hot air over Thunder Bay is rising and cold air is moving in. Go.
Justin's checking out the monitor to see where Thunder Bay is.
No. Yep, there you go. That's it. Okay, treble cone is in the southern hemisphere, and it's July.
Justin also going straight for the sun.
No.
Wrong icon.
Nope.
Listen to the question carefully.
Treble cone is in the southern hemisphere. It's July.
Justin's going for the rain icon. Oh, but he changes his mind.
There you go, that's it.
Final question. Water vapor is condensing over Beijing. What's it going to be?
Justin's got the cloud icon, but where's Beijing? And Justin's found it.
All right.
And now we'll get Samantha and announce the winner. Samantha, you can come up now. Okay, and the winner is Justin.
Yes.
Good job.
Congratulations.
Good job, guys.
Thank you.
Thank you.
And now we have a question from Max.
Why are tornadoes dangerous if they're just air?
Yeah, how is air dangerous? I mean, I can just push it with my hands.
Well, Harrison, air could be dangerous. When the pressure starts going up and down drastically in a short period of time, it can cause some serious damage. I want to do a little demonstration on a tornado.
Okay.
And of course, tornadoes can cause some serious damage, as we all know. Look at that. The wind speed of tornadoes sometimes could hit over 400 kilometers an hour, over 250 miles an hour.
Whoa.
And the thing with tornadoes, they don't give you a lot of time to get away. They just pop up because the pressure goes down, the pressure goes up, and this is what happens. And that's why tornadoes are very, very dangerous.
That's crazy. Now to find out how dangerous tornadoes really are, let's talk to George Coronas, who's a real live storm chaser. He's out chasing storms as we speak. Hello, George. I see you're out in some terrible weather. You could catch a cold out there, you know?
Harrison, as a storm chaser, catching a cold is the least of my worries.
So first of all, I think the kids at home probably want to know, what is a storm chaser?
Well, what I do is I try to get up close to the most dangerous part of the storm and then send in my reports so that people downstream of the storm can get those reports and hopefully save a few lives.
That sounds pretty risky. Why are tornadoes so dangerous?
Well, it certainly can be dangerous. It's not so much that the wind is blowing, it's what the wind is blowing. Pieces of debris, which could be branches, bricks, cars, sometimes even houses.
Wow.
So have you ever been inside of a tornado?
I have actually been inside a tornado once before with debris flying around. It's a very, very scary experience, one that I don't want to do again.
How'd you end up being right inside of a tornado and stuff?
Well, sometimes a tornado will change its path. I'll be tracking the storm and it will change direction, and sometimes I have to get out of the way. It's a force of nature. It can be very unpredictable at times.
So what technology do you use to help you chase?
Well, I've got all kinds of technology here in my storm chase vehicle. I've got my laptop computer that has satellite and radar imagery. I've got all my radios that I can use to send my reports in to the National Weather Service, GPS, all kinds of gadgets. It's basically a mobile command center on wheels.
So I'm pretty sure everybody watching wants to know, where do you go to the bathroom when you're chasing storms?
When you're on a storm, Harrison, anywhere you can. Anywhere you can.
That's a little awkward.
Sometimes it is. There's not a lot of trees out in Kansas, so you just have to find a place, and it's not always easy.
Do you get any adrenaline going when you're chasing the storms?
Absolutely, it's a bit of an adrenaline rush, especially when you're up close to a tornado and the wind speed can be several hundreds of kilometers per hour. I'd be lying if I didn't say that I got some kind of adrenaline rush out of it.
Do you have to ever, drive away or, run away from storms or tornadoes?
There's been numerous times where I've had to get out of the path of a tornado to turn tail and flee. I try to do a dangerous thing in as safe a manner as possible.
Yeah.
Oh, looking at the radar right now, it looks like I might have a developing tornado on the horizon.
Are you gonna go out and chase that right now?
Yeah, it looks like I'm gonna have to blast west here. I have a developing tornado.
Wow.
Hold on, let me get the radio here. Yeah, this is George K. relaying a message. It looks like we might have a tornado forming just to my west. I'm gonna try and intercept and get closer. Harrison, I gotta go.
Well, thanks for being on the show, George. It was great to have you, and I guess you have to go chase this storm.
Okay, I'm headed straight for the tornado. Stay in touch.
Okay, be safe. Bye. Whew, George sure does love his scary weather. Speaking of scary weather, here's a question from Samantha.
Why does hail hurt so much?
Ah, hail. The snowball's angry cousin. Usually a raindrop grows until it's too heavy, and then it will fall to the ground. Matter of fact, let's check back in with my buddy, the raindrop.
Hail is created when the raindrops, instead of falling down, get blown further up to colder air. The raindrops freeze into ice, get bounced around by the wind, and get bigger and bigger until they get too heavy and fall.
This means that instead of having a gentle drop of rain, you have a painful fall of ice. Ah! It's like waking up in the middle of a snowball fight. Watch these clips that George sent us!
On George's last storm chase in Nebraska, he found hailstones as big as baseballs.
Man, weather is no joke. I've found out a lot about weather, so I think it's time to answer
Joy's question that started today's episode.
How come weather just changes to other weather, like first it's hot, then it's cold?
The big answer is... there's lots of reasons.
The tilting of the Earth changes the seasons. Wind blows when the sun heats up the air. Water vapor forms clouds, and clouds block the sun.
But there's no clouds here today, so I'm gonna go outside and enjoy the beautiful day. See you next time for more Finding Stuff Out.
I'm in this watery world because of a question from Amelie.
Will water ever be extinct?
I don't know, Amelie, but I've been thinking about water, mainly because a water line broke in my street, so they turned my water off. But before they did, I managed to fill up all these containers. Hopefully by the time they turn the water back on, I'll be able to answer your question.
Now here's a question from Vanessa.
How come we can't talk or breathe underwater?
Why can't we talk or breathe underwater? Well, Vanessa, I found out for you. When we talk, our voice makes sound vibrations. What I'm trying to say is that we don't hear very well underwater because our eardrums need to vibrate, but underwater they don't vibrate as well. And the reason we can't breathe underwater is that while both air and water have oxygen, our lungs can't get oxygen from the water, and fish's gills can't get oxygen from the air. But wouldn't it be cool if you could breathe in both places? Now here's a question from Luisha.
Why do people need to have water?
If you're a fish, then you need it for breathing and living in. But humans use water for lots of things. We need to drink water because most of our body is made up of it. About this much. Hey, whoa, how did he get in there? Anyway, I feel a song coming on.
H2O, 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 H2O.
Well, there's water sloshing round in you and me. It carries nutrients to our whole body. It lubricates our joints and dissolves our food. Carries off our waste so we stay feeling good. We lose it when we poop and sweat and also when we pee. So we need this much water daily.
H2O, 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 H2O.
We use water to have fun too, like swimming and playing a whole bunch of sports. And most of all, we use it to grow food. Vegetables, fruits, and farm animals all need clean, fresh water. We also use water to stay clean. To cook, to make electricity, to paint, to heat our houses, to travel, to drink, even for flying. Water's everywhere, in everything. You're gonna make my head explode. Water's also nice in a cool cloth after your head explodes. But I realize that because it's so precious, we have to use it wisely. So, Luisha, your question inspired me to go and get some...
Street farts.
What I want to know is, who are the biggest water wasters in your home?
My sister, because she goes into the bathroom to do her makeup, but she has the tap running, and she doesn't need the tap running.
Me, because when I water the garden, I goof off with the hose instead.
Probably me, because sometimes I leave the water on while I'm brushing my teeth.
Me, because when I take a shower, I keep it on the hot and I'm in there for 20 minutes.
Probably me and my brother, because sometimes in the summer we'll use our slip and slide. And then afterwards we'll go inside to dry off and have a snack. We'll just leave it running, and that wastes a lot of water.
Looks like we should all stop wasting water. All we gotta do is turn off the tap. Now here's a helpful question from Matthew.
How does water beat fire?
To find out why water beats fire, I've come here to meet firefighter Mark Messier.
Hi, Harrison. Welcome to Station 36. Harrison, we've got a fire to go to. Let's go. We gotta go.
Let's go. Tell me you were taking me to a real fire?
This is the training center. This is where we train firefighters, so we're going to train you to put the fire out. Okay, so take the nozzle.
Okay.
Take some hose. Okay, you have one hand on there, one hand on here.
Yeah.
When it's full, you go ahead and open it up a little bit. Okay, now we got water.
Okay.
That's it. And spray the whole thing, go around in circles if you want. What we can do is we can roll around to the other side, make sure we get all the whole side. That's it. We want to cool down the fuel, and that will put the fire out. There you go. Now we can stop, see if there's any more smoke.
A little bit on the hay
It's
there.
still smoldering a little bit, and
yeah.
that's normal.
To answer Matthew's question, how did the water beat the fire?
So basically, when we look at a fire, it's like a triangle. You need fuel, you need heat, and you need oxygen in order to have a fire. By eliminating any one of those three, the fire goes out. So what did we do here?
Well, let's see. We didn't remove the fuel. The wood's still there. We didn't remove the oxygen. The air is still all around us.
We took the water, which eliminated the heat.
That's correct.
And that put out the fire.
That's exactly what happened.
Nice.
Good job.
Now we're gonna try to put out another kind of fire, a grease fire.
We can't extinguish all fires with water, because some fires will actually make it quite dangerous if we use water. Watch this.
Oh, that looks really dangerous.
It is. When people have a grease fire in their kitchen, the best thing for them to do is just to get out of the house and call 911 as soon as they can.
Right. Well, I'm sure there's some other way to put this fire out.
Yes, there is, by removing the oxygen. So what we're going to use is a carbon dioxide extinguisher.
Okay.
And you're going to put out the fire.
Awesome.
Carbon dioxide is the same gas that makes fizzy drinks fizzy.
All right, so you ready?
Yeah, let's do this.
Okay, let's go.
Ready?
Because it doesn't burn and is heavier than air, it sticks to the base of the fire and pushes the oxygen away.
Whoa, that was difficult to put that one out.
No, but you managed to do it. So when we look at our fire triangle, we have heat, oxygen, and fuel. What did you do here?
We sprayed it with the carbon dioxide, which got rid of the oxygen.
That's correct. We displaced the oxygen, so the fire has to go out.
Nice.
Good job. Okay, here we're going to have a propane fire. Now, we can't put this out with water. However, we'll use water to keep the tanks cool, and we'll use it as a shield so we can get close enough to turn the fuel off.
Oh, that's like the last part of the triangle. You just have to eliminate the fuel.
Exactly, and you're the one who's going to be turning it off.
Nice.
Uh-oh. You have got to be kidding. To put that out, I'm gonna need some special safety equipment.
Okay, now there's some clips back here we're gonna tighten.
Like that.
Now breathe. Okay? I checked you. I want to make sure I see no exposed skin. Something goes wrong, we need to make sure that you're covered.
Let's do this.
The gas leaking out of those tanks is on fire. The firemen will hose it off to make it cool enough to touch. My job is to turn off the valve and stop the flow of gas. But first, we have to get closer. That's the valve I have to turn off. I did it! Fire's out. Whew, that was hot. Thanks so much for being on my show.
Hey, no problem. Thanks anytime for coming, but you never asked me one question. How do we cool down after it's really hot?
How do we cool down after it's hot?
Well, you really want to know?
Yeah.
I guess that's a pretty good way to cool down. Here's another question that's all wet.
Why is the water clear, but the ocean blue?
Yeah, what gives? This glass of water doesn't have any color in it. Or does it? To help me find out... She knows about water, and she promised not to dump it on me. Please welcome Roxanne Moranger.
Hi, Harrison. Today we're going to talk about water.
All right, but you're not going to dump that on me, are you?
No, I'm not a firefighter.
So this is clear water, but I was hoping you could bring blue water to help me find the answer to the question.
Actually, all water is blue. You got to think of the sun sending down all its light like a rainbow into the ocean, but the only color that's actually being reflected from the water is blue, and that's why the ocean is blue.
So I guess you need a lot of water, like a lake or the ocean, to see the blue. Just one glass isn't enough.
Absolutely.
But what about all these colors, like this one?
Oh, that one, that's Lake Rotorua in New Zealand. It's covered in little tiny microscopic plants called algae that are green, and they're reflecting the green color.
Right, so that's why it's green, it reflects the green light. What about this one?
Oh, isn't that one pretty? That one's Lake Hillier. It's in Australia. It's very, very, very salty. It's like 10 times saltier than the ocean. And the little tiny microscopic plants growing in this lake actually reflect the colors more like orange and red.
So it ends up being pink with the salt and stuff combined?
Exactly.
Okay, and what about this one? It's black.
This lake is actually on top of a volcano. The water is coming in from underneath, and what's happening is it's gathering all the minerals from the rock.
Right.
And because it's a volcano, the rock is really black and minerally.
Right, from like ash and stuff.
Exactly, and so that's why it gets this black color.
Right, well, I have one more. It's rainbow.
Oh, Harrison, you're such a joker.
Okay, so what about this water? It's green. Is that because of the algae you mentioned earlier?
Absolutely.
Well, let's take a look at this with my super zoom-o-matic.
Oh, cool. So algae are little tiny microscopic plants. So you have to think of them as being like leaves of a tree, but they're really, really tiny. You can only see them with a microscope or your super zoom-o-matic. And they're the ones that are capturing the sunlight's energy and producing the food that all the animals living in water rely on to eat.
Right, and what about this water? It's all brown.
Yeah, that water is swamp water.
Oh, it smells horrible.
I know. Well, what happens is swamps are characteristic of a lot of things coming into it and dying. And as they die, they get all broken down and the color becomes brown.
Well, I wouldn't want to drink that. And Devin had a question about that.
How can you make river water safe to drink?
Some rivers are actually safe to drink right away, but most rivers you should take some precautionary treatment before drinking them. I have my filtration setup that I use when I want to go and study lakes.
Right.
And what we're going to do is we're going to pour a little bit of this water, which looks relatively clear. It has a little tinge of green.
Kind of green there.
Yeah, I wouldn't drink that directly,
Yeah.
so let's remove some stuff. Okay, so pour it in there. Let's get the filter pump going. And what I have in here is a little fine mesh filter that is capturing all the particles. So let's stop that. And let's take a look.
Whoa, it's all green.
That's the algae being caught up. Now, another way to make water safe is by boiling the water.
Boiling water, how does that help?
Well, you get the water up to such a high temperature that all the microorganisms or bacteria die.
Right,
So,
and then it's safe to drink.
Then it's safe to drink. So would you like to kill some bacteria?
Sure.
Let's go for it. So Harrison, the river water is now boiled, and now I'm gonna make tea. And tea is actually gonna explain why that swamp water we have over there is turning brown, because tea—
it's brown.
That's right, tea are just dead leaves.
Just like there's dead leaves in swamp water, dead leaves make tea.
Absolutely. Would you like a cup of tea?
Oh, why, yes. A cup of dead leaves would be wonderful.
My pleasure.
Smashing. This one smells much better. Thanks for being on my show.
My pleasure, Harrison.
Now here's a question from Mia.
How does rain come down from the clouds?
The Flat Earth Corner! Hey, farmers. Are your crops brown because it hasn't rained in months? Are your animals thirsty? Do you not have any water? No problem. Give me all your money, and I'll make it rain with this Rain-O-Matic air cannon. Why, this is no ordinary cannon. What a bargain! Less than 100 years ago, people believed there were rainmakers that could actually make it rain. It didn't work. Serious scientists tried it too, with a process called seeding clouds, but that didn't really work either. If there's no moisture up in the air, then you can't make it rain. Simple as that. Here's the real way rain falls from the clouds. The sun heats water in the ocean's rivers and lakes. The tiny droplets evaporate and rise up in the sky to form clouds. If enough water gathers up there, it gets too crowded for all that water, and it falls back down to Earth, starting the cycle all over again. But rain doesn't fall evenly all across the world, as Evan's question points out.
How come some countries in the world don't have that much water, yet most of the world is filled with water?
Most of our planet is covered by water. That's why it looks blue when you see it from space. So it seems like there should be enough water for every country in the world. But here's the thing. Let's say this is the entire amount of water that's in the world right now.
Nearly all of it would be salt water and oceans. We can't live by drinking salt water. Our bodies can't take that much salt, and we can't use salt water to grow crops or raise animals either. So how much is left of fresh water? The stuff we use for farming and drinking? Only about this much. But there's a catch. A lot of that fresh water is locked up in icebergs and glaciers. And what's left for us out of all the water in the world is about this much. I'm starting to see why some countries have less water than others. So because water isn't spread out evenly in the world, and some people have to work really hard to get their water, that gives me an idea for...
My Great Challenge!
Today's challenge might get very messy and very wet. And today's challengers are Michaela.
You're going down.
And Sam.
All right.
All right. In North America, each person uses this much water every day. That's for drinking, washing our clothes or cars, and watering the lawns.
It's crazy.
What if I told you you have to carry that much water on your head?
Whoa.
Watch this. People in some parts of the world spend as much as 4 hours a day carrying water from wells to their homes. Some people get so good, they don't even have to hold on to their bucket. As a matter of fact, that's today's challenge. You'll have this bucket, and you have to dunk it into this well, get as much water as you can, and then put it on your head and walk all the way to those jugs over there without spilling it. You'll have 2 minutes, and the one that fills the jug up the most will be the winner.
Okay.
But there's a catch. You cannot touch the bucket while it's on your head. If you do, you'll have to restart back over here.
What's this for?
This is to help balance the bucket on your head. Are you guys ready? Set, go! Don't touch the bucket.
Oh, yeah.
There's one, there's one. Going for bucket number 2. Oh, come back, come back. Oh, let go of the bucket. Oh, no! Make sure to let go of the bucket right before you start marking. They each have 1 bucket right now in their jugs, but let go of the bucket. Okay, okay. Oh, Michaela's almost there. Yeah. We have about a minute left. Oh, look at that, speed run. Michaela's going for her 3rd bucket, and so is Sam. Oh, they're tied right now. Sam's getting ahead. Oh! This is a close race. Oh! 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, time's up. All right, let's see who the winner is. So it looks like Sam has about 2.5 liters of water, and Michaela 3 liters. You're the winner.
Oh, yeah. I told you you're going down.
You really did.
What was the hardest part of the challenge?
Well, it was kind of keeping the water on your head because, like, you're trying to run, and it's a race, so it's hard to keep it on your head.
It was hard to put the right amount of water because if it's too heavy, it'll tip over, and if it's too light, it'll tip over too because there's not enough weight on your head.
So would you like to carry that much water on your head for 4 hours every day?
No.
Not really.
Really makes you think about not wasting water, right?
Yeah.
Yeah, well, thanks for being on my great challenge and helping me find stuff out.
That was really fun.
Yeah.
People aren't the only living things that have to worry about how much water they use. Here's a question from Angela.
How does a cactus produce water when there is no water in the desert?
I checked, and here's what I found out. These cactuses manage to live in deserts where other plants would die because there's not enough water. Cactuses do it by storing water and using it very carefully. This cactus doesn't have any leaves, so it doesn't lose water through them like other plants do. But the cactus can't make any water. It can only store water. So that brings me back to the question that started me on this watery quest.
Will water ever be extinct?
The big answer is yes and no. There's lots of water around, but not all are in forms that we can use. All of the water that's on Earth has been here since the Earth was formed. There's no new water being made. So even though there's a lot of water, we still have to conserve it and make sure it's clean, because there's only so much of it. Hey, sounds like my water's back on. Guess I won't have to break you open after all. Ow! I wasn't actually gonna break you open. Thanks for watching Finding Stuff Out. Ow! I don't even like cactus water. Ow.
Check out these new shoots. Great job, Freddie. Oh, Jerry, you're looking a little thirsty. But don't worry, Zoe to the rescue. Too much water. That reminds me of a question I got from Nora.
How come sometimes there's too much water, but sometimes there's not enough water?
You're right. Some places get flooded and other places turn bone dry. I know why there wasn't enough water in here. Either Jerry drinks a lot of water or I forgot to water him. Yeah, I forgot to water him. And then I wasn't paying attention and I gave Jerry way too much. So to answer your question, I've come here to Science World to meet Brian, who knows a lot about water. Hi, Brian.
Hi, Zoe.
I've been wondering about water, like how there's too much and sometimes there's not enough.
Well, Zoe, the planet is over 70% water. In fact, there's more water on Earth than there is land. So we're going to look now about how water can move from one place to the other.
Cool.
One of the ways it does this is through evaporation. Big lakes and oceans, the water will heat up and travel up into the sky.
Oh, forming clouds.
Yeah. Safety first.
Thank you.
We're going to try the same thing using a little bit of rubbing alcohol. This evaporates very easily. Ready? 1.
Pumping air increases the pressure and heats up the gas. We're gonna release all that pressure when we pull out the nozzle. That makes the gas cool down fast and transforms it into tiny droplets of liquid, which form a cloud. Got it!
We let the pressure go, temperature goes down, and we have a cloud in a bottle.
Cool. Look at that.
That is awesome.
Same thing happens with real clouds in the air. When water warms up, it evaporates into a gas. When that vapor rises and reaches the sky, it cools down and turns into clouds, which are tiny droplets of water that always find their way back down to Earth. Speaking of that, Maddie has this question.
How does a flood happen?
Well, flood happens when you have too much water. That could be too much water that's built up behind a dam or a dike that's broken through, or it could be too much water coming down from the sky in a big storm. So Zoe, I've brought you a house and a beautiful lake here. Where would you like to place your house?
Let's place by the lake, because I like the lake.
It's true. A lot of people like to be close to the water. Of course, water also likes to flow down. I'm going to turn the water on.
All right.
All right, the water's starting to flow. We've got a gentle rainstorm up in the mountains starting to come down. Maybe a little bit of snow melting up there.
Oh no! Oh no! My house! My new carpet! My new book collection!
That is one soggy house there, Zoe.
I guess we'll have to find a better place for my home.
Sounds like a plan. One thing people can do to help protect houses from water is build dikes and water gates to redirect the water away from where you want it to go.
Let's try and see if my house will go right here.
So this time it's not moving at all. Of course, in big heavy rains, sometimes the dikes will overflow or even break.
Oh no! My house!
I hope you have insurance.
Well, even with the dikes here, I don't feel like my house is completely safe. Oh, this is a great place for my house.
Looks good, Zoe. Nice high ground, safe from a flood.
So the higher you are, the safer you are from a flood.
There's less water to flow through, that's for sure.
I have a question about floods. How high could a flood get?
Floods have been recorded as high as 6 meters.
Am I there yet?
Higher.
Am I there yet?
That's it, 6 meters.
Oh no! Whoa, I made it.
Nice job.
I
have a question. How do you get rid of a flood?
That's a great question. As the climate's changing, a lot of people are thinking more about how they can prepare themselves for a flood. In fact, here at Science World, we're looking at the water levels around us and realizing they could go up as much as 1 to 2 meters.
Well, then what do you do in a flood?
The main thing is to stop the water from coming in and dry out the areas that have been affected. This could be using big blowers, heaters. One of the main things is make sure you get all of the moisture out of carpets, furniture, walls, because you don't want any mold starting to grow inside. Everything has to be completely dry.
Well, thanks for the tips. I think it's time we tested them out.
Yeah.
My Great Challenge!
Today's challengers are Ophelia and Nick on Team Turbulence.
Team Turbulence!
And Cecilia and Louie on Team Wildwater.
Team Wildwater.
When I say go, I'm going to release the marble floodwater, and your job is to swoop in and save the day by directing the flood away from your houses below. The team with the fewest marbles around their houses by the end of the challenge wins. Are you guys ready?
Yeah!
Okay. And go!
Oh. No, 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 no. No, 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 I swear. Come on. I'm going here. Go.
Challengers have 2 ways to stop the flood. Using their sandbags, they can divert the rush of the water marbles onto the other team's side or into the drain holes on the edges of the river.
No, no, no. Come on. I'm going here.
Trying to push the marbles upstream is useless. They're only going to go back down. Water is really hard to stop.
Come on. No, 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 no.
That's it. No more water.
Judging by the number of marbles around the houses, it's clear that Team Turbulence won.
Yay, Team Turbulence.
Good job, guys. You fought the flood like superheroes.
Flows across the plains. It fills up all the drains. When there's too much water, it can really be a pain. When cold, it turns to ice, and we slide around like dice. There's snow that's fun to play in, but ice storms are less than nice. Oh, yeah.
Next question.
Why are there ice storms?
Well, Leah, I checked, and this is what I found out. An ice storm is a storm of freezing rain that covers everything in a crunchy, slippery coating of ice. It happens when frozen rain falls through warm air, which melts it before hitting the cold ground, which freezes it. This forms a layer of ice on trees, cars, a sidewalk, everything. That's why it's always important to check your weather forecast so you can be prepared for anything. But what if you can't look up the forecast? That reminds me.
How do animals survive in a wild weather?
Oh no, a dog can't look up the weather. A cat can't check the forecast. A moose doesn't have a weather app. An elephant can't look up the temperature. Who warns the porcupines and the monkeys?
You're gonna make my head explode!
Whew. Some people think animals have a sixth sense because of all the crazy, cool ways they predict and survive wild weather. But they're just way more observant than us.
Animals tune into the world while we humans have trouble paying attention. Bees sense changes in the air pressure that often lead to rain, so they know exactly when to head inside. Sharks notice big temperature changes in the ocean, meaning the storm's coming, and swim to safety. Most land animals go somewhere high and safe in a water disaster, like this clever dog who survived a flood by swimming up to the roof. Before a tsunami, elephants sensed movements in the earth and went to higher ground, trumpeting and warning each other.
I wish I had a built-in trumpet to warn people of tsunamis. Veronica has a question about tsunamis.
How do tsunamis start?
Flat Earth Corner! Konnichiwa, people. Did you know the word tsunami is Japanese? It's from su, meaning harbor, and nami, meaning wave. Here in 7th century of Japan, we believe Namazu, a giant catfish, lashed its tail, making a giant wave.
Oh, come on. We know now, rather than a giant fish, tsunamis are caused by natural events like landslides, volcanoes, glaciers breaking, and earthquakes. Whoa! 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 I found out that when the earth moves, water moves to fill the gaps.
In a powerful earthquake, the earth under the ocean can be lifted or dropped, which causes gaps. The water above it rises and makes giant waves across the ocean. As the water moves closer to shore, waves get bigger. A tsunami can move as fast as 1,000 kilometers an hour. That's faster than a jet plane.
The experiment!
My friends made a tsunami simulation. Hi, guys.
Hey, Zoe.
Hey, Zoe. So how do you make your tsunami?
First, we use newspaper, dirt, and sand to build our beach.
Then we add some houses and trees to make it more realistic.
Time for the sand. Do you like beaches? Of course.
The highest tsunami wave ever recorded was in Alaska.
Now for the water. I can't wait.
It was 524 meters, about as high as the CN Tower.
Now it's time for the big wave. 3, 2, 1.
Millions of trees were uprooted and swept away. The powerful wave washes up on shore, and as it flows back out, it pulls just about everything along with it. Yikes. Thanks, guys.
Bye, Zoe.
Bye, Zoe. What a crazy place the ocean is, and I'm not the only one who thinks so.
Are there volcanoes underwater?
Well, Emily, I found out that deep beneath the waves, there are about 1 million volcanoes. That's more volcanoes underwater than above. Here's how to make your own.
First, we start with cold water, representing the ocean, then a bowl of hot water, representing the lava-filled volcano. So, we have this little cup, and we're gonna fill it with warm water. Next, we put some red food coloring to make it more lava-y. Stir it up. Then, we put the tin foil on, and you wanna make it as tight as you can. Next, we poke a hole, representing the opening of the volcano.
Whoa. Unlike on land, when a volcano erupts underwater, lava doesn't shoot out because there's so much ocean weighing it down. So you can be in a boat over an erupting volcano and never even know it was there.
Don't worry, little volcano. We know you're there. There are a lot of things happening in, under, and even over the ocean. That reminds me of a question I got from Sophia.
How do hurricanes form?
Hurricanes are pretty picky. To form, the conditions have to be just right. First, they like warm ocean water. Next, we need a lot of wind. Clouds pull water from the ocean up, which makes a tube of super speedy air. This makes a hurricane. Hurricanes are water-moving machines. They suck up water from one part of the planet, and spit it somewhere else, sometimes making floods.
Today, weather scientists make an alphabetical list for the year's coming hurricanes. Zena, York, Zelda, but no Zoe. Phew.
Next question.
How do you respond to hurricanes?
We find out more about hurricanes called Sammy or Rosie or even Elaine. I call my special guest, and Dr. Kirsten's her name.
Hi, Zoe.
Hi, Dr. Kirsten. I asked you to come over to be on my show, not move in.
Well, I came prepared for a hurricane.
There's gonna be a hurricane?
No, the forecast is clear, but it's good to be prepared.
So Amelia wants to know how to respond to hurricanes. That's kind of your job, right?
That is my job. In fact, my job is not only to respond to hurricanes, but to respond to natural disasters or humanitarian emergencies all over the world.
Wow.
I have some pictures of the places I've been. There's one from Haiti, the Philippines. Both countries were affected by earthquakes and hurricanes.
That's crazy.
Sudan, which is affected by drought.
So it must be hard working in natural disasters.
You know what? It is tough because you don't have the luxuries that you have in your own home. So you have to bring everything for yourself. So it's kind of like camping in a way. We bring our own sleeping mats and, of course, our own sleeping blankets or sleeping bags. In some of these countries that are affected by hurricanes and a lot of water, there are mosquito breeding grounds, which can cause disease. So it's important to bring our own mosquito nets. That keeps us safe from getting mosquito-borne illness at night. Something else that we bring is our own food, because in a lot of these places, people don't have enough. So this is called a ready-to-eat meal. It's one prepackaged, dehydrated meal. All you need to do is reheat or add water, and you're ready to go.
You even bring toilet paper?
Yes, we do. Often in these places, the toilets have been destroyed or they don't work. And so we bring our own toilet paper, but we also bring this system called a pee-poo bag. So these bags are biodegradable and they can be used for human excrement, feces, or urine. And you put your paper inside, wrap it up, and you put it into a pile, and that it can be used for fertilizer for future agricultural initiatives.
That's weird.
Practical, doesn't leave any waste behind. We also need to bring our own ways to make water clean. In these places where there's a lot of water, like in a hurricane, all the water gets mixed together. So often it's not safe to drink.
Yeah.
And so what we often do is bring these kinds of devices where we can actually put a filter into dirty water.
Wow.
And it filters out all of the bad stuff, and you can pump your own water that's safe to drink, just like that.
Wow. This is a lot of stuff you bring to a disaster. I'm gonna ask my friends what they would bring.
Ask a friend.
Hey guys, what else would you bring if you already had the essentials?
I would gather all my construction blocks, bring them with me, and then grab my tablet.
My piggy bank and my stuffed animals. Because you can't bring your bed.
A hockey stick and a hockey puck. I would bring my favorite doll because I can't sleep without it. My teddy bear. It would be a hard choice to decide between my stuffed monkey and my parents. Because I love my stuffed monkey and I love my parents. Yeah, and I would bring a swimming suit to swim.
It seems like there's been a lot more water disasters lately.
You're right, and that's largely due to climate change. And, you know, sometimes not having water can be just as much of a disaster as having too much water. Here's a picture of Lake Chad, which is in North Africa, and it's only 10% of its original size. So you can see how this area that used to be all filled with water is now shrunken down to a fraction of what it originally was.
Dr. Kirsten told me that with climate change, there's been less rain and more drought. Also, there are a lot more people living around Lake Chad, so more people use up the water resources. Same thing is happening in the Aral Sea. Look at how it shrunk in only 25 years. A big part of it is now a desert. People need to be really careful about using water.
You know, in Canada, it's like we use 100 of these buckets of water per person for eating and cooking and washing a day. But in some of the places I've visited, people only get 3 of these buckets a day. So you can imagine how much difference that is and how much more water we use.
Well, thanks for helping me find stuff out.
Oh, you're welcome, Zoe.
Not bad, Jerry. Oh, you really bounced back from the flood. Still looking good, Freddie. I think I'm ready to answer the question that inspired today's show.
How come sometimes there's too much water, but sometimes there's not enough water?
The big answer is... water moves. That's right. Water moves around the Earth all the time, but natural disasters make it move even more. Tsunamis push seawater onto land. Hurricanes suck water from the ocean and spit it somewhere else. Snow melts, and all these things put water where we don't want it. Then there are the places we'd like there to be water, but there isn't. Sometimes this is normal. But other times, drought and other water disasters are made by us. That's right. I mean you and me. But if we're prepared for a natural disaster, it won't be so disastrous. I hear a storm coming. It's pouring! Quick, gotta get an emergency bag ready just in case. Hey, where are the people bags? I can run super duper fast. I want to be the fastest kid in my class. Maybe even the whole school. But I'm still not fast enough. That reminds me of a question I got from Faith.
How do you make things go faster?
That sounds easy, but some things just don't move very fast. Like, if I throw a piece of paper with all my might, it still won't move very fast. I don't know the answer yet, but I promise to find out by the end of the show how to make things move faster. But first, here's a real quick question from Ella.
What's the fastest thing in the world?
Good question. The fastest land animal is a cheetah. It can reach speeds of 120 kilometers per hour. That's faster than the speed limit on a highway. The fastest vehicle on land is a rocket sled at 10,325 kilometers per hour. That's 31 football fields per second. It's used by the U.S. Air Force to test equipment. What? The Juno spacecraft can go 265,000 kilometers per hour as it whizzes through space. 265,000 kilometers per hour? It's like going around the world in 10 minutes. Or going to the moon in an hour and a half. It's 80 times faster than a bullet.
You're gonna make my head explode!
But how do things get to move so fast? To speed things up, please welcome Canadian Space Agency engineer, Kumi Jinadasa.
Hi, Zoe.
Whoa, that was fast.
I love going fast. Follow me.
It looks like you love going fast as much as I do.
Actually, I really do. When I was a kid, I was really interested in how fast things move and why they move so fast. With my job at the Canadian Space Agency, knowing how motion works really comes into play in every single piece of equipment that we deal with. Whether it be an astronaut doing a spacewalk, blasting a rocket off into outer space, or how a rover moves on different planets.
What's the difference between going fast on Earth than in space?
To move fast in space, it's actually a little bit easier because on Earth we have two different forces. The first is gravity.
Oh yeah, when I jump up, I fall down.
Exactly. The second force is friction. What would happen if you stuck your hand out of a car window that's moving?
It's like going back and forth.
It's pushing you because there's a resistance, and that is air friction.
Oh, kind of like when I throw this piece of paper, the air slows it down.
The air does slow it down, and it falls to the ground because of gravity. But in space, that piece of paper would continue moving for a very, very long time because there's no air.
What if I wanted to make things move faster here on Earth?
Well, Zoe, follow me. Hey, what took you so long? I have something to show you. This is actually a picture of me when I was in grade 10 at my science fair. And I have a device here that I made that demonstrates the effects of friction. Here on the table, we have a really similar device. Basically, we have a box, and there's two hair dryers with holes in the box so the air can go into the box. And then I have this piece of hard plastic, and the air comes out of these holes. I want you to observe how this cup moves on the smooth surface.
Okay.
It stops.
Yeah.
Let's observe what happens to the cup if we turn the air on.
Okay.
So what did you observe?
It was like the cup was floating.
That's right. The air made a thin layer on the surface and the cup wasn't in contact with it. So there was no friction. In my science fair project, I also wanted to observe different levels of friction with different materials. Okay, let's take this styrofoam mat. How do you think the motion's gonna be?
I feel like there's gonna be a lot of friction.
Let's see. It barely moves.
Yeah.
This has a lot more friction than the smooth surface. Let's try with the wood.
Better, but still stops.
Yeah, let's try with bristleboard. Still has a lot of friction.
Yeah.
If we have no friction, this cup can move faster and a lot easier. And that leads us into the first law of motion.
An object at rest stays at rest, and an object in motion stays in motion. Unless acted upon by a force.
We can demonstrate the second law of motion playing a game of air hockey.
I'm in.
Let's do it.
Wah! I scored!
Nice! What do you think would happen if this puck was heavier?
It probably wouldn't move as fast.
Want to try?
Yeah.
Let's use this as a weight on top of the puck. And I'm gonna use this ruler so that I could push both pucks at the same time with the same force.
Okay.
I scored!
Yeah. The lighter one went way farther.
That's right. What do you think we need to do to this one to make it move just as far?
You need to push it harder.
That's right, Zoe. We need more force.
Law of motion number 2. To move something faster, you need to push harder.
To demonstrate the third law, we have these two identical rolling chairs.
Push!
What did you notice about the motion?
Well, we both went back, but I went further because I'm lighter.
That's right. What would happen if we were the same weight?
We would both go back the same distance.
That's exactly how the law is stated. For every action, there's an equal and opposite reaction. A good tip to make things move faster is to keep these laws in mind.
Thanks for helping me find stuff out, Kumi.
You're welcome.
Bye.
Bye.
The experiment!
Hi, Fabiola, Aaron, and Shakib.
Hi, Zoe.
What's your speedy experiment today?
Today's experiment, we're going to use some playing cards, some empty water bottles, and some objects we found around the house. Fabiola has some loose change that she found, Aaron has some hex nuts, and I have a battery. What we're going to do is apply a force to our playing cards and then see what happens to our everyday objects.
Yes.
Yeah.
Hooray!
How did that happen?
Now, our playing cards are much lighter than our everyday objects, so when we applied a force to the playing cards, they went flying away. But our battery is much heavier. When our playing card moved out of the way, there was an empty hole in the top of the water bottle, and gravity did the rest for us.
So, the heavier the object, the easier it is?
That's right.
My trick was harder than yours because my hex nut is lighter than your battery.
And my trick was harder than both of yours because my dimes are lighter than your hex nut and your battery.
Absolutely correct. But I do have another experiment to share with you, Zoe.
Awesome. Now we're gonna do the tablecloth trick.
What I'm going to do is take some water and pour it into my cups here. 1, 2, and 3. Next, what we're going to do is build a little bit of a tower. So I've got a bowl, a cup, a plate, a bowl, a cup, and then again, a plate, a bowl, and a cup. What I'm going to do is pull on the tablecloth, and hopefully the whole tower will stay standing and the tablecloth will get pulled from underneath. Are you ready, Zoe?
Yes.
Here we go. 3, 2, 1. Ta-da!
Wow. What about you, Aaron? Awesome. Fabiola, you try.
Oh no, you weren't fast enough.
Speed makes all the difference. Thanks, guys.
Bye, Zoe.
That makes me think of something my friend was wondering.
What's the fastest object in sports?
Is it a hockey puck, a soccer ball, a tennis ball, a baseball? It's none of these. I found out it's a badminton birdie.
Hey.
The record is 493 kilometers an hour. Whee! That's almost 4 times faster than the fastest fastball in baseball.
Badminton birdies may be the fastest sports object, but badminton isn't actually the fastest sport.
I wanna see fast, and they're gonna show me. Table tennis experts, Wenbin and Tommy. Hi, Wenbin.
Hello.
Hi, Tommy.
Hi.
You guys move crazy fast.
Thanks, Zoe. Although badminton birdies can gather the most speed, table tennis is actually the sport where the athletes require the fastest reaction times.
Reaction time is the time between when a person notices something and reacts. Or not.
Because of the ball speed versus the table length, table tennis players need to react really fast. And sometimes when the ball comes too fast, you actually have to react before your opponent hits the ball in order to react to your opponent's ball.
What? Before he hits the ball?
In order to do that, you need to look at your opponent's positioning, his body language, how his shoulders are placed, and how he prepares for the ball.
Wow, you hit that ball really hard, and it still hit the table. How did you do that?
In order to hit the ball really hard and still make it land on the table, you need to put spin on the ball. In this case, you need to put top spin. When the ball goes in that direction, there is air resistance countering the ball in the opposite direction. When the ball spins like this, there's something called the Magnus effect. When the top of the ball hits that air resistance, that creates pressure on top of the ball and less pressure on the bottom. That makes the ball drop, so you can hit hard and still make the ball drop.
Oh yeah, the ball is dropping way sooner because of how you hit it.
We can also put side spin, so the ball can spin in this direction, in the other direction, or even underspin, which makes the ball spin in this direction.
Cool, can you show me?
Did you see how that ball turned?
Wow, they're really fast. I wonder how fast my friends' reaction times are. It's time for...
My Great Challenge!
Today's challengers are Maxim and Kenny.
The challenge for you is to see who can hit the most balls against Tommy.
Maxim, you'll go first. Ready? And go!
Challengers get 2 rounds. Maxime is volleying like a pro. 15 balls. He's off to a good start.
Kenny, you're up. And go!
Wow, Kenny's going really fast. He'll beat Maxime's score if he keeps us up. Oh no, 14 balls. One more would have tied it up.
Okay, Maxim, you're up again. And go!
Maxime is ahead by 1. Can he hold on to his lead? Both challengers are giving Tommy a run for his money. 13, 14, 15. He's doing better in round 2. Oh no, 18, and he's done.
Okay, Kenny, and go.
Kenny needs to keep that ball alive if he wants to catch up. 18, 19. Wow, Kenny takes the lead. How many more can he hit? He's like a table tennis machine. 38 balls in round 2. Awesome.
The results are in.
33 for Maxim and 53 for Kenny.
Kenny, you're the winner. Good job.
Uh-oh, do try this at home.
How about checking out your own reaction time? My friends have a simple way to do that. Hi, Kenya and William.
Hi, Zoe.
Show us your trick. It's called the ruler drop. When you catch it, look at the number on the ruler.
10.
The lower the number, the faster your reaction time.
17. 8. 29.
And who's got the fastest reaction time?
Me.
Thanks, guys.
Bye, Zoe.
Next question. It's from Laura.
Is it possible to fall out of the roller coaster if it's too fast?
Great question, Laura. I asked my friend Shakib to answer that. Take it away.
I love roller coasters and loop-de-loops, but how do those cars stick to the rails? We're going to use a large yellow bucket, thank you, Zoe, and then a pail of ping pong balls. As I spin it around, I'm changing the acceleration and creating something called centripetal force. That centripetal force sticks my ping pong balls to my big yellow bucket. Would you like to give it a try, Zoe?
Sure.
Go ahead. Wow, that's great. Now, as Zoe spins that bucket faster and faster, there's more force created and the balls don't rattle around anymore. But if Zoe slows down any... Oh no! We made a big mess.
So, going faster on a roller coaster keeps you safer?
Absolutely. The faster you go, the safer you are.
I really do love super fast roller coasters. Thanks, Shakib.
You're welcome.
I asked my friends why they like it.
Ask a friend.
It feels like you're going so fast that you can't feel yourself.
It's like I'm lifting off the seat. It feels like I'm skydiving. I like the wind in my face. It like tickles your stomach. I kind of feel like I'm free. It feels good. The best thing ever. I love being scared and I get scared a lot. The speed makes it fun.
That kind of speed would have scared people not so long ago.
Flat Earth Corner!
Taphophobia is a fear of speed and going fast. And let me tell you, I've got it bad. I'm zipping along on this new invention called a bicycle. Crazy! They say if I go too fast, I'll get bicycle face, like this. Uh-oh! Now I'm on a train, moving even faster. Our bodies weren't made to travel at incredible speeds of 50 kilometers per hour. Our bodies will melt. Oh dear, now I'm in a car. This is crazy. I'm a girl. Girls can't drive this fast. We'll faint. What? Girls not allowed to go fast? That's nutty. People in the past had some strange ideas about speed, and it scared them. But I love to go fast, and the human body can deal with very high speed.
On the ground, one driver zoomed at 1,223 kilometers per hour in a jet-propelled car, Thrust SSC. In the air, pilots have flown 7,275 kilometers per hour. In space, astronauts have flown 40,000 kilometers an hour.
So people in the past had nothing to worry about. But all this speed talk makes me want to move faster and faster.
I love to run fast. I love to move quick. I love to zoom and zip. My moves are so slick when I hit the track. I don't look back because I love to run fast. Woohoo! Yippee! I love to make tracks. I love to vamoose. I am booking and I'm cooking and I'm jetting loose when I hit the track. I don't look back because I love to run fast.
Look at me go. I've never run so fast. Wow. I can't believe I was racing with champion sprinters Tatiana Holu and Deandra Green.
Tatiana and Deandra are amazing athletes. They competed in the Commonwealth Youth Games and brought home medals. They work super hard at going super fast.
What an honor it is to meet you.
Nice to meet you too.
Nice to meet you, Zoe.
My friend has a question.
How can a human run faster?
We ask ourselves that all the time.
And I know someone who can help us with that. This is my coach, Rashiddin.
Hey, Zoe. I heard you really want to run faster.
I do.
I can help you. First thing to do is to time you so we can tell that you're improving. Ready to race?
I was born ready.
On your marks, set, go. Great job.
Thanks.
All right, so let's see if we can improve this. But most importantly, we're going to change your clothing.
Okay. Check me out. I look so fast.
Those form-fitting clothes will decrease wind resistance. That's the friction from the air that was slowing you down before.
Oh, I get it. My slick new clothes decrease friction, just like the plexiglass in Kumi's air table. What about my shoes? My friend Adriana was wondering...
Why do shoes make you run faster?
The right shoes can make you run faster, but not those. Try these. These shoes help you stick to the track, and it allows you to push off the track without slipping.
Wait a minute, that's friction. My slick clothes decrease friction and wind resistance, but my shoes actually increase friction with the ground, pushing me forward.
That is correct.
Okay, I'm all suited up. What's next?
First thing is your body posture. Stand up straight, hips in front, arms 90 degrees bent. Pull one arm back while the other one comes right in front of you. What's important that this hand that's in front is to your mouth level. Remember, keep your arms close to your body. Stay tall at all times. And your knees. Very important to raise your knee up high and pull your toes up. Then down. Push back and then forward. Push back. Good. Are you ready to race?
I sure am.
It's not always about winning, but it's really important in achieving your personal best with some stiff competition.
Another race with Tatiana and Deandra? This is the best race day ever.
Set. Go!
Good job, Zoe.
Thanks.
Good job, Zoe.
Guys, really well done. Zoe, you ran 1.6 seconds faster. A new personal best.
Woohoo! Thanks. I've been fast and speedy and raced my way back to answer today's big question.
How do you make things go faster?
The big answer is increase the force and adjust friction. In Kumi's experiment, we saw that less friction made the cup move faster. On the racetrack, less friction for my clothes, but more friction for my shoes helps me go faster. Also, increasing the force on something makes it go faster. And if you have a quick reaction time, you're on your way to a fast victory. Oh yeah, new personal best. I'm out of here. See you next time for more funny stuff. I missed again. I really have to work on my aim. This is my little robot, Roland. He finishes the job for me. I'm controlling him like he's my little robotic assistant. Mwahaha! I am the puppet master, and you will do as I say. Controlling a robot like this is really handy. But what if it was attached to my body? I found out that people can get artificial body parts if they were born without an arm, or a leg, or lost one in an accident, or because of illness. They're called prosthetics. But I don't think they're robots like Roland. No way. This question from Jada is what got me thinking.
Do prosthetics make you bionic?
Bionic? You mean like having superpowers? I'd love to be bionic. Wouldn't you? Cool! Not to worry, Captain. I gotcha. I'm stronger, faster, super bionic Zoe! Jada, I'm not sure prosthetics give us super bionic powers, but I promise to use my super finding stuff out powers to get the answer. I'll start with this question from Massimo.
How does it feel to get prosthetic limbs?
To answer that, I have a special guest today. Her name is Megan, so please say hey. Welcome to my show.
Hi, Zoe. I can answer all your questions by showing you my prosthetic legs.
Oh, you have 2 prosthetic legs, but you walk so well.
Nothing stops me.
When did you get your prosthetics?
When I was 2, I got a sickness called meningitis, and they had to amputate my 2 legs and 9 fingers. A year later, when I was 3, I got my prosthetic legs. It hurt at first, but once I got comfortable, I was actually proud.
Here's something Tristan wants to know.
Does a prosthetic hurt?
Yeah, does a prosthetic hurt?
No, because it's fitted for me. If there's anything that actually hurts, they can switch it around.
Are there any sports or things you can't do because of your prosthetics?
My prosthetic legs don't stop me from doing anything. They help me do things. My favorite sports are basketball and snowboard.
What other sports and activities do you do?
I kneeboard, I go on tubing. I have a bicycle fitted for me.
That's cool. I see you have other prosthetics here.
Yeah, for the past year I've been wanting to wear high heels, but I couldn't because my regular prosthetic legs don't bend at the ankle. And we got these made that actually bend at the ankle.
That's cool.
Yeah.
Hey, I love your nail.
Thank you. It's my only nail. I like to take care of it.
Is it hard to do other things without your 9 other fingers?
Well, I can text as fast as my friends can.
That was fast. Do you have superpowers?
No, I just get used to doing things my own way.
Well, thanks for helping me find stuff out, Megan.
No problem. It was fun.
Yeah.
The experiment!
We're really lucky to have prosthetics to help people. My friends try to make one with straws. Hi, Andalyn and Nicholas.
Hi, Zoe.
I know you can't make real prosthetics like the ones Megan has.
Right, but we can make a cool robotic hand using stuff from around the house.
Go for it.
We're gonna use 5 bendy straws, 1 for each finger, to make a hand.
And tape them together.
What's next?
Now we're gonna make little marks for the knuckles. Now we bend them at the knuckles.
Make a little cut in the corner.
Now we put the string through the straws.
And tie a knot at the top. Zoe, check this out.
It's pretty basic, but it works.
The strings are kind of like muscles that make a regular hand move. Thanks, guys.
Bye, Zoe.
That gives me an idea for...
My Great Challenge!
Today's challengers are Nora.
Hi.
And Dina. How do you like your new homemade prosthetics?
They're cool. Not fashionable.
Today's challenge is like getting ready for school, except while using your prosthetics. You have to pour some water, make a peanut butter and jelly sandwich, and take a bite. And put your notebook and pen in your bag. Sound easy?
No, simple.
There's more.
What?
You have to put your jacket on and then come to this table and write your name in your notebook. Oh, and it's a race. First person to finish wins. Are you ready?
Yeah.
Okay, go! First step, spread peanut butter and jelly to make the sandwiches. Looks like you're having a little bit of trouble there. It's not easy holding a spoon with homemade prosthetics, is it?
There we go.
They each have to take 1 bite of their sandwich and have 1 sip of water.
This is gonna be tasty.
Dina's ready to bite into her sandwich. Done. I guess she doesn't like peanut butter. Nora's having a hard time getting the peanut butter out of that jar. But Dina's struggling with her glass. There's the peanut butter.
Beautiful.
And there's the jelly. Dina's got her straw, but Nora's got her sandwich made. Dina takes her sip, and Nora's catching up.
Ready for school.
Now they've got to pack their bags and put their jackets on. Keep going, guys.
Oh, shoot, my jacket.
After a slow start, Nora's caught up. They're so close. But Nora's having trouble getting her coat off the rack. Dina's got her arm in. She's getting ahead again, but Nora's not far behind. Uh-oh, Dina can't get her second arm in.
Oh, no.
Nora's got her jacket on.
Dina's having a little bit of trouble over there. Oh, my goodness, my sleeve.
Keep going, Dina.
Shoot. Yes.
Way to go, Dina. Now get out your notebook and write your name. Nora's getting ahead.
Dina, I like the technique.
Oh, no. Shoot. Whoops. Pick up that notebook, Dina.
And...
Done.
Oh, no.
Okay. Nora wins.
How do you put on a jacket?
So what was the hardest part?
Probably putting the jacket on and spreading the peanut butter on the toast. Same with the jacket situation, but writing your name, seriously.
Well, our prosthetics were homemade, but I got this question from Amber.
What are prosthetics made of?
Need new hand? Look no further than Blacksmith Bob's Best, the only shop with the best materials, the best tools, and the best replacement limbs in town. We forge each and every one in heavy, extra strong metal. Behold this iron hand. It does not bend, it does not flex, so it will never break. That's the beauty of iron. Get them while they're hot. Oh, it's fresh out of the forge! It's so hot! There was a time when prosthetics looked like pirate hooks, and they were made of metal that didn't even bend. I think it's really different today. To help me find out how prosthetics are made, I brought two special guests to come to my aid. Please welcome to my show, Nicholas Marchand and Carolyn Vio.
Hi, Zoe.
Hi, Nicholas and Carolyn.
We brought some prosthetics for you today, Zoe. And I'm wearing mine. I won't squeeze you too hard.
You can squeeze harder?
Mm-hmm, I can.
That's a very firm handshake you got there.
Sure is.
These all look super cool, but Amber wants to know what these are made of.
All the new prostheses are made out of a black material called carbon fiber, the same material that we make race cars and jets out of.
This one looks a little bit old-fashioned. It's not the same as all the other ones.
This is my first prosthesis. I had it 40 years ago. You want to see how it works? This was a bit harder to use than nowadays prosthetic. So by pulling my shoulders forward, it pulls on the cable here and makes it open.
It kind of looks like a pirate hook.
You're right, Zoe.
But it seems like it must have been pretty hard to use.
And not that useful. So I chose not to wear a prosthesis for quite a while. And then I got into sports. And even though I could do anything with just one hand, I got some prosthetic made for sport, like this one. I used it to ski. It even got me to the Paralympics, where I got a gold medal.
Wow.
And I have other adapters. See? I just switch, and there I can go and play golf.
Wow.
I have another one for cross-country skiing, where the pole goes here and allows me to cross-country ski. This is for swimming.
Oh yeah, it kind of looks like a paddle. That's really cool.
Yeah, but today, prosthetic can do much more.
Like this one?
Yes, Zoe, that's what we call a myoelectric hand. Myo means muscle, and electric means it's powered by electricity. Your muscles on your arm generate a signal that in turn power the fingers of that hand.
What muscles make it move?
Let me show you.
I'm just flexing the muscles in my arm.
See how you close those fingers? Now close them fast. You're making those fingers work.
That's really cool. But my hand is more than open and close.
That brings us to this hand. It's called the Quantum. It is the most advanced hand in the world for myoelectrics. And this hand actually allows you to choose from 35 different grips. If I wanted to hold a plate, I would activate the plate grip, whereby I can take the plate, put it right under the thumb, close down on the plate, hold it, and then bring it wherever I want.
That's really cool.
If you want to use a keyboard, you can use your finger to press a keyboard. So depending on what you want to do, you can make the hand choose that grip for you.
That's super cool. Here's a question I got from Olivia.
How come running blades don't look like real legs?
Yeah, how come they don't look like real legs?
Well, that's a good question. So most running legs work like a spring. This is a running leg that belongs to a boy. When that boy runs, he puts weight on the leg, it bends, and then bounces forward, pushing him forward.
So do blades like this give someone extra running power?
They don't give you extra running power. They only give you the power that you put in.
Well, that was awesome. Thanks for helping me find stuff out about prosthetics.
You're welcome, Zoe.
You're welcome.
Check this out. I found out that there's some really amazing technology out there for prosthetics. This artificial hand can actually feel things like a real hand. But this question from Antoine really made me think.
How do you survive without arms?
Uh-oh, do try this at home. To get an idea of how hard it is to do simple things while missing an arm, try this. Try tying your shoe with one hand. It's really not easy.
Okay, it's tight. Now I just have to make a bow. Almost got it. Oh, got it.
Finally. Surviving with no arms must be really tough.
Prosthetics are super helpful, but I found out they can cost a lot of money, and people can't always afford them, especially in really poor countries.
But I found out that today we can use 3D printers to make them.
A 3D printer heats up stuff like plastic to build an object like the artificial hands these kids are wearing, made specially to fit their size. And because they're a lot less expensive than other prosthetics, it means that when kids grow, it's easier to have bigger ones made for them. These 3D limbs are changing lives for kids around the world who might have lost limbs because of war. Now, they can do lots of the same things other kids do. Hey, those prosthetics are really fun looking. Maybe I'd make myself an extra arm.
Sweet. I wonder what my friends would want.
Ask a friend.
If you could add an extra part to your body, what would it be?
Wings, so I could fly.
It would be a robotic arm that could it could activate anything. Like if you want a pencil, it could just activate a pencil.
An arm that the hand, it shoots spider webs like Spider-Man.
Legs, so we can run really fast and always win a race.
Feet that could fly, so with jetpacks on the bottom. Gills, so I could swim around and stay underwater for as long as I wanted.
Now here's a question from William.
Can animals have prosthetics?
Bionic. There's only one place to find out. At an animal hospital.
Hi, Rajan.
Hi, Zoe.
So can animals have prosthetics?
Sure, like humans. I designed some myself.
Cool. Can I see one?
So this is Gypsy?
Hi, Gypsy. Do you have superpowers? Yes, you do. You're super cute. What happened to her leg?
Well, she's born with one leg shorter than the other one, so we made a prosthetic.
I like how it's pink. How long has she had it?
Almost 1 year. All right, now I'm going to take off the prosthetic device, okay? Just to check the leg. There you go. I'll take off the socks.
Is it a bit better now?
Right now, yes, because her leg was weak because she wasn't using it. Now that she is using it, it's much stronger. You have more muscle here.
That's great. Are there any other animals with prosthetics?
Absolutely.
It turns out that lots of different animals can get prosthetics if they need them. This duck lost her feet, and Rajan made prosthetic feet for her. He also helped out a bunny rabbit.
This is Daisy, and she got sick. And the back leg doesn't work anymore, so I designed kind of a wheelchair.
That's so cool. She's so cute.
Now she can walk without dragging her back leg. That was causing her a lot of problems.
That's amazing, Rajan.
Hi, Maria.
Hi, Zoe.
You do physical therapy with animals?
I sure do. It helps them to adjust to their new prosthetics. We're going to start with a little massage. It's going to help to relax Gypsy's muscles. You're going to make circular motions with your thumb all the way along her spinal muscles because they get tired from carrying her prosthetic. Go ahead.
Do I do it this way?
Sure. What's important is to not get on the bones, but to stay on the muscles. Gypsy seems to really be enjoying that.
This looks like an exercise ball I've seen before, but never shaped like this. It looks like a peanut.
It's shaped this way to be able to support a dog's body.
All these exercises help strengthen Gypsy's back.
Gypsy has a lot of pressure on her back by carrying this heavy prosthetic, so we need to make sure it stays good and strong for a long time.
She'll be stronger than ever after this. Thanks for helping me find out about animal prosthetics.
You're welcome.
And thank you, Gypsy. And here's a question I got from Rowan.
Could a person who's paralyzed walk with a prosthetic device?
I checked, and it's possible.
There's a special suit called an exoskeleton that helps people who are paralyzed or have difficulty walking. It's kind of like a robot that you wear. Moving your weight a bit to one side makes the robotic leg on the other side take a step. There's another exosuit that anyone can wear. It helps people in construction or other physical jobs. With the exosuit, they can lift heavy things without tiring out their muscles as much or getting hurt.
That seems almost like science fiction. Maybe I could have an exosuit that could let me time travel.
Wow! Nice T-Rex! Yeah, sure you can fly, but can you do this?
All this high-tech stuff has me wondering the same thing as Megan.
Can you control a prosthetic with your mind?
I found out you can.
Scientists have been testing this amazing technology that lets a person with missing limbs move an artificial arm the way we use regular arms.
By mind control. They're still working on it, but it's super cool. And guess what I've used mind control to do? Get the answer to Jada's question that started off today's show.
Do prosthetics make you bionic?
Well, Jada, the big answer is... yes, they do.
I found out that bionic means using machines to help us do things, sometimes as a replacement body part. Prosthetics are like small machines that help people walk, ski like a champ, or throw a ball.
So prosthetics make us bionic, but they don't give us any superpowers.
Huh? They don't?
Well, at least not yet, but maybe in the future.
I am future Zoe, I'm not far from today. The things I can do will blow your mind away. Everything you're dreaming, it is coming true. Swim like a fish, have super hearing too. X-ray vision, bionic eyes. Hey, I can see you ate a lot of French fries. Half human, half machine, a cyborg you could be. And fly so high that from the sky the whole world you would see. I am future Zoe, I'm not far from today, but I still have to clean my room and put my toys away. Come on, future me, let's get this done.
In the meantime, I have Roland to help me out. Thanks, Roland. See you next time for more Finding Stuff Out.